Is the audio okay, guys? Whoever is on the live meet now, just type okay. If you can hear me properly, just type okay. Okay, good. Thanks, Aman, for that. Others, I hope you can hear me properly, and I was a bit worried about the audio quality, but this is the best I can do. Okay, so we'll wait for some moments. Let your friends join. I'll be here, but let me mark myself on mute. Yes, good morning. So there is a 10 seconds delay typically in YouTube Live. So between the time you respond and I respond back, or vice versa, that's the kind of delay that will be there. So keep that in mind. Good morning, all. Good morning. We will get started in another 5-10 minutes. Let me see how many of you are here. Okay, a lot of your friends are missing. Let them join. Good morning, all. Good morning. Good morning. Good morning, everybody. Okay, so we have 60 of you almost here. I see 59, but that's okay. And we are almost on the top of the hour. So we'll start. I wanted to be on time because there is a lot of things we have to cover. So I'm sure your friends would trickle in as the time goes by. But let's try to be on time on the sessions. If I can be on time, I'm sure you can be on time. So good morning to you all, and some quick disclaimers before we start off. Just wanted to hear from you as an okay if my audio is good, my video is good. Okay, thank you. So now that we have the infrastructural challenges set and dusted, what we'll do is we'll try to structure the day. You already know how we'll structure the day. I've given you the schedule. We'll try to cover Unit 1 and Unit 2 today. Unit 1 we'll cover in the first half and Unit 2 in the second half. That is the plan. So that's how we will proceed, and I guess we can finish off the first half early, if I am not mistaken in terms of the content that I have for you. But the second half is going to be a bit dicey, so let's see if we can push some topics into the first half if we finish off early. So that's on this part. Some basic discipline. Of course, YouTube Live is a muted chat only, so you cannot speak, understand. Every one of you is time boxed into a 10 seconds delay between two messages, just to prevent spamming. And then of course your only method of communication is through this chat box to me, and my only method of communication to you is what I hear from you from the, or what I see from the chat box is what I hear from you. So that way the chat box becomes very important for both of us in order to make merry out of this session. So let's try to utilize the chat box to the best of our abilities for a productive and meaningful insight. Yes, you can also use WhatsApp, but it's better to keep everything in the chat bot, so that if the recorded sessions are published, then the chat also gives meaningful insights to people who might be watching the recording at a later point in time. So that's for Zeniki1729 who asked that question. Now I would prefer all your questions coming up here, because my WhatsApp, though it is open, I might have muted it for the betterment of this session. So we will try to accommodate that in that context. Now I see we have 89 of you already here, and I would expect this to grow as the time goes by. So let's start off without any further ado. We are at 9:01. Why we are here? We are here to see that if we can tame the so-called DSA animal in the next 24 hours. Right? So that's why we are here, 8 hours per day for 3 days. If we can actually utilize these 24 hours to listen to these lectures, understand these lectures, then I am sure you will not need to study anymore in terms of DSA. Yes, of course, a basic refresher will be required, and if you are noting down what is being discussed, my PPT notes will be with you after the session. Then I'm sure you would have no other books to refer, no other topics to refer. Everything here will be something with which you can score an O or a E. That's my belief. Rest is up to you, how you want to absorb these sessions, how you want to make yourself engaged in these sessions. That's more important. If you don't engage, then it will be a monologue from my side only. So I will keep on asking questions. Please utilize the chat bot to answer it. We will have quizzes and I have planned some 4 quizzes for the first half, and I think some 4 more for the, or 3 more for the second half. At the end of this program, all the quizzes will be aggregated together in terms of the score the top 3 participants will receive some amount of goodies that Techno India or Techno International Newtown is planning to share with you. So that is on the quizzes that will be conducted. The quizzes are there for you to probably participate and make sure that the earlier lesson that you learnt through these lectures are suitable enough for you to answer those questions. Of course, some of them will be of a very easy standard, some of them will be of a medium standard, some of them will be of a hard standard also. But it's not going to be too lengthy quiz, maximum 5 to 7 or 10 questions maximum. So those are the that's on the quizzes. So wait for the first quiz after the first topic, that is algorithm fundamentals, which we will finish off in the next 1 hour. So 105 of you are here now, so it's probably the right time to probably introduce myself. Hello everybody, my name is Kallol Bhattacharya. Some of you know me, some of you don't. And for people who don't know me, I have spent around 25 years in the IT industry with various Fortune 500 companies, TCS, Infosys, Wipro, Cognizant, and then finally 1.5 years back I retired from there and joined the Techno India group to be with you in terms of making you understand what are the best practices of the industry and how to probably shape you better in terms of the gap that the industry sees between what education is provided in the colleges versus what the industry needs. So that's my main charter. Enough about me. It's more about you here. How do we make you prepared for DSA? So let's get started on that. If you have any questions, please feel free to ping on the chat window. I will be coming back to the chat window probably 5 to 7 minutes intermittently because this chat window will not be open on my screen. So I'll have to do an alt tab for that. So don't expect an immediate answer, but please keep posting your queries on chat window and I'll come back and I'll answer to all of them. So this is what we will cover, which is on the screen, which you already know. So let's get started with the first topic, which is our algorithm fundamentals. And the way we'll structure the entire 8 hours, or rather 24 hours, is that we will not create it as a theoretical concept or a theoretical topic discussion. We will try to align it with the kind of questions that are asked both in Makaut as well as in GATE as well as in other universities. So I have taken 3 sources of questions and I will try to teach you all the topics that is part of your syllabus through these question answer sessions or the question answer way that I have put up in these slides. So I'll not get into the theoretical concepts and then get into questions against that. I'll try to avoid that. 90% of this, what you see, will be aligned to questions that are commonly asked, be it in terms of Makaut questions last 10 years or GATE, or for that matter any other university questions. I have taken some 2-3 university questions also into the scenario and tried to aggregate all of that into a flow so that we can cover module 1, module 2, module 3, module 4 through those questions itself. That gives you 2 advantages. It is not going to be a boring theoretical lecture, which I hope so, and it's not also going to, it's going to be very close to what you can expect from the actual examination purpose. So that way it will serve both the purpose. So we had when we were 6 months earlier, when we were doing our C classes, right, we had understood about primitive data structures. So this was your primitive data structures, where you learnt about data structures and how you stored an integer, how you stored a float, how you stored a character, etc. Right. So now you have grown old, right? So you are 6 months older than what you were before. So there is no more primitive. So everything now has become non-primitive for you, right? So the non-primitive data structures for you, you have already or you would have already heard about linear and non-linear. This is one question that is very favorite. Difference between those two and what are these? So linear data structures are those where the sequential methodology of movement of accessing the data, what we call as traversal, right? So if you traverse through a data structure from its beginning to the end, then the movement will be sequential in a linear data structure. For example, in an array, you will start from the 0th index and then only move from 0th to 1, 1th to 2. Even if you start from in between, from the fifth, you can only move forward or backward. So it's a line that you can actually draw in terms of the movement. You cannot do a haphazard way of traversing through a linear data structure. So that is on the linear data structure. These are the examples, all of them. Arrays you have done, linked list will cover, stacks, queues will cover. Non-linear data structures, both trees and graphs will cover, and these non-linear data structures are typically your hierarchical data structures where the traversal is hierarchical. And when we say traversal is hierarchical, storage is also hierarchical, traversal is also hierarchical. So while your linear data structure will be stored like this, like stored like one after the other. If this is an array, it will be stored like this. If it is a linked list, it will be stored like this, right? So which is basically to point out that there is a line between the two nodes that will stitch them together, and every movement happens along that line, right? And you cannot actually jump things in a linked list for that matter. Hence it is something that you need to be aware of. Stacks and queues, again the same thing. You cannot jump the queue, you cannot jump the stack, you cannot pop out a different element other than the top element. So everything will happen in a sequence, in a normal linear sequence. Whereas in a tree-like data structure, you will have a hierarchical representation of the nodes, and these hierarchical representation of the nodes will give you the ability to actually move from, let's say, from here to here, and probably go back again and come back here to here. So these kind of movements is definitely possible. Like a haphazard movement like this is definitely possible when you go through around in a tree. So which means that we are talking about sequential storage, we are talking about traversal in a forward or backward direction, and of course that creates less flexibility for us, and the examples we have already talked about it. So for a non-linear data structure, the flexibility is much more, and hence a typical question that is asked is, if the elements of a data structure are stored sequentially, then it is called as, now the answer can be array, linked list, stacks, queues, but then that's not probably the most appropriate answer. The appropriate answer will be the group, which is the linear data structure. The elements of a data structure is what they are asking. If the elements of the data structure are stored sequentially, it can be an array, it can also be a linked list, it can also be a stack, then what do? You will group them together and answer. So always remember, in fill in the blanks, they might not give you choices. So when you come around with multiple correct definitions or correct answers, please select the most appropriate one. In my classes, I have seen people answer arrays or people answer linked list, and which is something that you should not mistake for this particular simple answer, right? This has to be, the answer has to be linear data structure, because we are talking of all the 4 parts here as a part of the answer of this question. So that's on the algorithm fundamentals as far as the linear and non-linear data structure is concerned. So that's a very important topic. Beyond that topic, if we move forward, then typically very easy questions, and these are from your C days that are being asked. What is the disadvantage of an array data structure? Of course, you know that in an array, you will have to define the array with the dimension of the array when you are actually initializing it. So we are saying that int ARR 10, this 10 is something that you will have to tell it upfront, right? If you want to tell it beyond the static code, that is in terms of a dynamic loading of the memory, then you will have to rely on syntaxes like malloc and calloc, right? So that is something that also you should be knowing from your C days. But then the disadvantage is this, that I have to tell it that my fixed size will be 10, right? My fixed size being 10 means what? My fixed size being 10 will mean that I have to be very cognizant of the fact that I have to utilize those 10 so that those 10 spaces will not get wasted, or if I need more spaces, I will not get those more spaces, right? So I have to be very meticulous in terms of understanding how much pockets I need at the very onset of writing a program, which is very difficult for anything to happen, anybody to probably guess. For example, your class of, let's say, 65 people suddenly becomes 66 when, let's say, a lateral person joins in your class. So if we had created a 65 pocket static array, we could not have accommodated that person into that array, right? So that way this becomes the major disadvantage of an array data structure. Next, if you see the data structure is a particular way of, now what is a data structure? Anything that is a structure can be seen around in the physical world. Any structure can be seen around in the physical world. Any aggregation of data is a structure that you see around in the physical world. A pile of bricks is a data, or rather a pile of bricks is a structure. Now when you say data structure, it means that can that structure be pushed into a computer so that you can do various operations on that structure. So that is where the data word will come and marry with the structure, saying that structure is an aggregation of data or whatever information we have. Then can we push this into a computer system so that we can analyze this data and come out with various insights? What are the operations, like the push operations that you are probably aware of, pop operations? These are operations that we do on a data that is on a data structure, and this we can do on a data structure because it is available in our computer system, right? So on a physical world, right, the number of operations that we can do will be very limited. Whereas if you bring it to the computer system, then you can actually do multiple operations, for which you will actually realize that the data structure becomes very important for you to not only store the data in a computer system, or storage, if we actually take that kind of a word, a particular way of storage and organizing, or storing rather, we'll put it as storing. So what are you doing? You are bringing the data into the computer system. So storing, and what are you doing next? You are organizing, right? So these are the two verbs that you will use for this particular answer. As I said, you are bringing the data into a physical storage within a computer, so storage, and you are not keeping it haphazard. You will organize it either as a queue or as an array or as a tree. You'll organize it, right? So that way, that creates a data structure. Now once a data is stored and organized like a stack or a queue, then comes the fun part, where you can start your analytics. You can do a pop, you can do a push, you can do a peek, what all you want you can do with that data structure. So that's why the storing and organizing is important in this particular answer. In C language, malloc returns. So for that, this kind of question I think I saw in the C exam also in the last semester, and if I remember what I had told you in the last few lectures, where I took the same kind of question answer for malloc. Malloc doesn't care about the kind of usage that you will do with the memory that it gives. So we have to be very careful about what malloc does. In malloc, what happens is, if you are actually asking malloc, please give me 5 integer spaces. So you will say 5 star size of int. This is what you will say. Please give me 5 integer spaces. Malloc doesn't even care you asked it for 5 integer spaces. Why? Because this is not going to malloc as 5 star size of int. This gets first evaluated as 5 into 4, because 4 is a typical number of bytes for an integer. So this becomes 20, right? So 5 into 4 equal to 20. This 20 is what goes inside malloc. So what does malloc get? Malloc gets something like this. Malloc doesn't even know that you said this, because this is a compiler interpretation in terms of the execution of that expression will be evaluated before malloc gets called. 20 becomes the expression evaluation, and then malloc gets called. So when malloc gets called, malloc says, okay, you want 20 spaces, I will give you 20 spaces like this in memory, right? But that space, I don't know what you will keep, and it has to return me a pointer to this. So if this is at 1000, it has to return me a pointer to this. So if it returns a pointer, what is the type of the pointer it returns? It cannot return me any kind of a pointer that it knows that I will store that kind of a value. Does it know I will store int? No. So can it return int star to me? Can it return an int star pointer to me? It cannot, because it doesn't know that I will store an int. All it knows is I asked for 20 bytes. That's all it knows, right? So it will return me char star? No, it doesn't know that also. So what does it do? It returns me void star. That's what it does. And it says you define what you want to store. I am giving you 20 pockets. I am giving you 20 pockets for your fun. Do whatever you want with it. I don't care. But I will give you a void pointer. So that's why the answer to this question is void pointer. So if we move on to the next set of things that we plan to cover, how are strings represented in memory in C? Very easy. If you see a string which is let's say hello, then this hello string will be represented in memory as an array of characters, which is HELLO, and this is your array 0, array 1, array 2, array 3, array 4, and there will also be a /0 as a null terminator. We call this as a null terminator. So of course the answer is an array of characters, but the actual storage, if somehow some question comes that why does a string have a null 0 or a /0, that is a null terminator at the end, the answer to that is when the machine reads this particular address, whatever that address is, let's say 1000 is this address. When a machine starts reading this address, it needs to know where to stop. For an integer it is very easy. For an integer array it is very easy. 4 byte, 4 byte, 4 byte, 4 byte. So it knows that 79 is here, 89 is here, 65 is here, 50 is here. This is 4 byte. This is 4 byte. This is 4 byte. So each of the 4 bytes it knows that it will be a number. So it is asked to actually get that number. The number itself is 1 unit. So the 1 unit in this case is the entire is 1 number. But here the unit, 1 unit here is the entire string. So the string is not in one pocket. The string is in multiple pockets. So the string is not in one pocket. So in order to get the string, it has to move forward, 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 take every character till it reaches something called as the null character. And that's where you get the string back. But for an integer array, you don't need to, because the first pocket itself is a 1 unit. Second pocket itself is 1 unit. Whereas for a string, the storage or the sequence of characters is 1 unit, not 1 character. And that is the reason why you have a null character in the string. So that's on your algorithm fundamentals. Now, an interesting question that typically comes is this matrix flattening question, which is very important as well as very trendy in terms of the way it is being asked. So at least 2 questions are there. I'll attempt to take you through all of that. So what it says is, which of the following expressions which of the following expressions accesses the ij_n3 of a m by n matrix stored in column major? So let us take a column major matrix. Let us take a ij matrix, and we will take, for that matter, let's take a 5 by 4 matrix, right? So we will take 5 rows like this, which will be marked as 0, 1, 2, 3, 4, 5 rows, and 4 columns, which is marked as 0, 1, 2, 3, 4. I hope you are understanding and you know that this is a matrix, and this matrix here is what we call as M, and this is what we call as N. So in our case, M is equal to 5 and N is equal to 4. So this is what we have assumed. Now what is this trying to tell us? This is trying to tell us that if we have a reason to understand what is stored here, what is the value stored here? Some values are there. Suppose some values are there. Then how do we get to this value from a 1D array? Because this is a 2D structure. So from a 1D array, how do we get to this value? First of all, we have to understand what we are trying to do. We are trying to take this matrix and we are trying to say that it's a challenge to all of us. Store this matrix in a 1D array. 2D array we can understand, but store these metrics in a 1D array. So then what will we do? We will say that we will take out this particular portion. We will take out this particular portion. Or we will say that we will take out this particular portion. Right? So, and what we will say is we will take out this particular portion and then we will put it in an array. So let us do that. If we do that, then if we go by the column, because we are saying column major, right? Column major means what? Column major means we will go like this. we will take all these 5 blocks, store it in a 1D array. Then we'll take the next set of 5 blocks, store it back to back. Then we'll take the next set of 5 blocks, then we'll take the next set of 5 blocks. So this is how we will store the array in this particular way, right? So if we do that, then what will happen is let's draw the array. So there are what, m is equal to 5 and n is equal to 4. So you have 20 as the total number of pockets that you need, 20 as the total number of dimensions that you need in order to actually store these 20 elements, right? So let us create that. So if I create a 20 pocket array, right? So let me do that. This is going to be 10, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 4. So we have a 20 pocket array. Now in this 20 pocket array, this is my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 19 indexes, 20 pockets. Now with this in mind, how do we store this? We will take this entire block, and we will push this inside here, right? So what we will say is, so then this becomes my 0, 0, that is this element. Then the next element we are going down, right? Remember, we are doing a column measure, so we are going down. So the next element will be 1, 0, right? And the next element will be 2, 0, 3, 0, and 4, 0. And then this 4, 0, once this is done, we'll have to go up again. So we will do a 0, 1. So the next element will be 0, 1. So this is what we will store here, right? So then next element will be my 1, 1, 2, 1, 3, 1, 4, 1, and likewise. Now this is also done. So next what we will do, we will go up again. So next element will be 0, 2, 1, 2, 2, 2, 3, 2, 4, 2. So that is what we will do. Next, the last column is empty, or last column is left rather. So we will do a 0, 3, 1, 3, 2, 3, 3, 3, and 4, 3. So that is what we will do there. Now, when we do this, what did we achieve? We said all of this, whatever was inside this. So some, let's say 45 was here. Then 45 was stored in 0, 3. Where is 0, 3? Here. Here 45 was stored. That is what we are saying. So taking this array, that is this 2-dimensional array of matrix, and converting it into a 1D array. This is how we will do it, because we are told column measure. If we were told row measure, simple, we would have gone like this, same way, right? Same way, we would have flattened out this 2D array into a 1D array. Now I hope you understand this part of the concept. Now let us say that my element that is of interest is here. I want to know that in this array, where is this element? I already know where is this element, because I know that this will be at 1, 2. So 1, 2 is here. So which means my element is here, right? So you can see the element is there. This particular element will be available in a 1D array at the 11th index. Right? We all know that, we have seen that, or we are seeing that right now, right? So I hope you can understand. Now what they are asking you is that if you know that it is in the 11th index, can you give me a general formula to calculate this 11? From what? From whatever we know. We know m equal to 5. We know I equal to, they are saying, see, the ijth entry. Ijth entry is what I have taken. I have assumed I as 1. I have assumed j as 2. So they have not given us any I or j. I have assumed I or j. Right? So I as 1, j as 2. So these are the 4 things we know. What is j? J signifies column. What is I? I signifies row. So if you need any helper to actually help you with columns, you will utilize j. You will utilize n and j for your columns, and you will utilize m and I for your rows. When I say utilize, what does it mean? Let us see. So if you see that if we have to reach this 11, then we will have to go like this. We have to go one column down, then we have to go one more column down, and then we have to go a partial column down. So if we have to go 2 columns down, then what is this? Where is this 2 going to come from? We have to go 2 columns down. So this 2 will come from my J. I told you, right? Columns, please refer to J or N. Already J has 2. So J being 2 says that you will have to skip J times. You will have to skip J times. J times what? J times that many number of rows that are there. How many? So basically what that means is that you are skipping 1 row, 2 row, 3 row, 4 row, 5 rows. J times, that is 2 times. So 4 rows if you skip 1 time, then you cover this column. Another 4 rows if you skip, 5 rows if you skip 1 time, you will cover this column. Another 5 rows if you skip 1 more time, you will cover 2 columns. So those 2 columns are coming from J, the factor of 2 is coming from J, and the number of rows is coming from M. So this becomes your 5 star 2. That is 10 elements you are skipping. 2 columns, 5 rows, 10 elements to be skipped if we have to reach to this particular element. And after that, still have we reached? What is this? This is equal to 10. Have we reached our candidate? Our candidate was at 11. So we have to add 1 to here. We have to add 1 here to this particular output. But then to add 1 to this output, where is this 1 going to come from? From your I. Because I, again, as I said, you are now skipping rows. You are skipping 1 row here. 1 row here to get into the next element. And that 1 row is coming from your I, because I is your row helper. So M star J plus I will be equal to 11. Right? M star J plus I will be equal to 11 is the generic formula with which you can calculate the position of this particular variable, which is at a position of 11. But is it matching with an answer? It is not matching with an answer. The reason for that is because we started with a 0 index way of doing things. Right? Instead, if we start with a 1 index way of doing things, this 1 index way of doing things will actually make our lives easier, and then the answer would be M into J minus 1 plus I. Let's see if we can quickly do that also. Let me attempt to do that, so that you understand that in a 1 index way of doing things, the same answer would have been treated differently. So if I take the same array, same matrix, and if I say that I have 5 rows, 0, 1, 2, 3, 4, and I have 4 columns, 0, 1, again, my bad, we should start from 1 index, right? We said we will do a 1 index. This whole thought process of repeating it is to start with 1 index. So we will do a 1 index, 1, 2, 3, 4. And then what we actually do is we say that we want to go here, right? So that's all we do. And then our M is still 5, our N is what? N is 4, and our I now is 2, our J now is 3, because this element of interest is at row number 2, column number 3, right? So that's why our I is 2, J is 3. So if we flatten out the array now, if we flatten out this array and we break it up, then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yeah, so if we flatten out, then this becomes my and we are going, remember, we are going like this. So this becomes my 1, 1. This becomes my 2, 1. This becomes my 3, 1. This becomes 4, 1. And this becomes 5, 1. Right? So with that, we can now move to the second column, which is going to be 1, 2. Second column starts from 1 row, and second column, because it is second column, 1, 2. Then 2, 2. Then 2, 3, 2, 4, 2, 5, 2. Then we move to the third column. The third column is 1, 3, 2, 3, 3, 3, 4, 3, 5, 3. Then we move to the fourth column, which is 1, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4. So where is our element? Let us mark our element. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So where is our element? Our element is at 2, I equal to 2, j equal to 3. I equal to 2, j equal to 3, I equal to 2, j equal to 3. So I equal to 2, j equal to 3 is here. So our element is here. Right? So if our element is there, I equal to 2, j equal to 3. Did I make any mistake? Let me see. Yeah, the mistake is that because we have taken one index as the starting index, this also will be one index. Right? So this is something that you have to be consistent, because you are choosing the matrix to be one index. This also has to be one index. So this will be 1, 2, 3, 4, 5, 6, 7, 8, the way it goes in a one index mechanism. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this element that is of our interest is at position number 12. Now where is 12 going to come from? What are you doing? You are actually skipping one complete column. One complete column and two complete columns from here. Where is that going to come from? From your helper j, which is your column helper. So column helper will help you with that. So column helper will take j, but I have to do a -1 because j is 3. I am skipping two columns, so j -1. But each of the columns, how many rows am I skipping? 5, which comes from your m again, right? And we have discussed that. So these are the 5 columns, 5 rows that we are skipping, which comes from my m. So 5 columns skipped 2 times because 2 columns are there, or 5 rows skipped 2 times because 2 columns are there, will translate to what? Will translate to again 5 into 2, which is 10. How much left? We have to do 2 more. So we have to do 2 more. Where is that 2 going to come from? That 2 is going to come from your I, because those 2 are the rows that you are skipping, right? So the rows that you are skipping will come from the row helper, which is equal to your I. So that is why your generic formula becomes m star j minus 1 m star j minus 1 plus I, and that is what you will see as the answer to this particular problem. M star j minus I plus m star j minus 1 plus I as the answer to this problem. So I hope you have understood that the answers will be, whenever you see I minus 1, if you see I minus 1 like this, j minus 1, n minus j, if you see a minus sign with a multiplier, right, you will understand, you have to understand that it is a 1 index. If there is no minus sign, then it will be a 0 index. Like for example, we had calculated m star j plus I if it was a 0 index. If it was a 0 index, that is what we did just a few moments back, right? So for a column major, m star j plus I was the 0 index, and for a 1 index we have calculated m star j minus 1 plus I. Remember these two, because these two will be thereafter used in multiple formulas. One of the questions is this. So if you see here, one of the questions here says that suppose one 2D array is initialized with this, base address is this, find the location of the element A24 in a row major form and column major form. So it's simple enough. A row major form I will not probably do for the sake of time. I'm sure you can do it. Same way we have done the column major, same way you have to flatten the array, same way you have to calculate. But I'll do the same thing for column major, and you can understand the way we'll approach this problem. So the problem that we'll approach here is saying that suppose a 2D array is initialized as int a57. Whenever you see this, what does this mean? This means a matrix, right? A matrix where m is equal to 5, n is equal to 7, right? Then the base address is 4000. Okay, base address is 4000. Find the location of A24. This is your point of interest. Remember, point of interest we had marked as a star. This is my point of interest, right? So what does that point of interest translate to? Your I and j. So we will mark this as my I and j. So we will say I is equal to 2, j equal to 4. Now these are the values you are given. Now you know that in a column major form, for a 0 index basis, for a column major form, what you know is that m star j minus 1 plus I is what the formula for. Let us recap from here. See, m star j plus I is a zero index formula, right? So let us write that there. M star j plus I is a zero index formula. So m star j plus I. This is the formula for a zero index array when it is flattened out as a one from 2D to 1D. A particular position of that array, how can we represent that from the 2D perspective? So 2D perspective is m, j, I, n, right? Is the 2D perspective. How can we mathematically make an expression so that that 2D perspective becomes a 1D position of that particular array? That is the question. So if that is the question, zero index says m star j plus I. One index says index says that m star j minus 1 plus I. M star j minus 1 plus I. I told you, right? If you see a minus sign, it means one index, right? So that way you can also remember in case you want to remember it that way. So when we know this, we can apply both the things and we can actually give both the answers, or we can say that any one of them, saying that it is a zero index assumption or it is a one index assumption. You can assume any one and apply any one formula. So m star j plus I is what? M star j plus I. What is our m? 5. Okay, 5 star j. What is j? J is 4. Okay, and what is I? I is my 2. So what is this? 5 4s are 20, 22. 22 positions. 22 positions is what, or 22th position is what the array will be. So what it says is that this particular array, if it was flattened out, that 2D array, then on the 22th position we will find our element, which is A24, right? So that is what it tries to say. On the 22th position of that flattened 1D array is where we will find A24. Then if my starting address of this array is 4000, if the starting address of this array is 4000, then 22th position from the starting address is 22th position of the starting, 22 pockets away from the starting address of an integer array is going to be 1 byte or 4 bytes per integer. One pocket will be 4 bytes, and hence 22 pockets will be 22 multiplied by 4. So the actual address of this particular element will be 4000 plus 4 plus 4 plus 4 plus 4 plus 4 plus 4 till 22 times, right? So 22 into 4. Why 4? Integer is 4 bytes assumed. 4000 plus 22 star 4. So that will be 4088. That is one answer if you take a zero index assumption. If you take a one index assumption, the answer will be 5 star j minus 1. What is j? 4 minus 1 plus 5 star j minus 1. Yes, 5 star j minus 1 plus I. I's value is 2. So 5 3s are 15. 15 plus 2, 17th position. So 17th position from 4000. 17th position from 4000 will be the actual element which we are trying to seek, and hence multiply this by 4. So 17 multiplied by 4, 7 4s are 28, 2 4 1s are 4, 68. I hope I'm getting my numbers correct. 7 4s are 28, 2 4 1s are 4, yes, 68. So 4068 is going to be the answer unless I've got my maths wrong. So that's the answer to 4088 is one answer, and of course the other answer will be 18 into 4, 5 3s are 15, yes, 17. So yes, 17 into 4 and then 4000 added to it, 4068. So that's what is coming as a matter of fact from a one index problem solving standpoint. Now similarly, zero index and one index both will have a row major calculation, and you will probably be able to find it out. I keep it as an assignment for you, that find out what is going to be this answer from a row major perspective. What will be the answer both from a zero index and from a one index? So we can utilize some of the time that we will have tomorrow to actually debate about whatever answers you have got here. So we will leave this here. I hope you understood. So this is coming at least 2-3 times. This has come even in Makaut. So I hope that you have understood. All we are doing is we are taking a 2D array and we are actually flattening it out and saying that, okay, we have flattened out this 2D array, but what about this position? This position was what I was interested. I could easily address this position by saying ARRIJ. Now you have taken away that credibility from me by saying that everything is now flat like this. So I cannot say ARRIJ. I will have to say some array, let's say flattened array, flat array bracket something. Let's say P, flat array something, some index, right? I have to say. So how can this I and J be translated to this P so that I can know where to go in this flattened array, 1D array, to access my element? That is the question. The formulas I have given you, and you have to intelligently understand what to do with this 4000, because this was the starting address to this array. So this position is going to be that many number of pockets away from the starting address, and hence you will apply your common sense to actually add it up. So that's the array part of it, or the 2D array to 1D array conversion part of it. Coming to algorithms, if we define an algorithm, then the definition of an algorithm and the characteristics of the algorithm, if you see closely, they go hand in hand. So an algorithm is a finite. So what is a finite? It's also a part of the characteristics. There cannot be infinite number of steps in an algorithm. There has to be a finite number of steps which will end by a possible amount of time. So that is finite. And the steps cannot be any ambiguous steps. It should be well-defined steps. So step-by-step sequence has to be well-defined. It cannot be ambiguous, right? You cannot just say that. Run fast to that tree. What does fast mean? In your dictionary, fast means something. In my dictionary, it means walking. Right? So run fast to that tree is an ambiguous set of instruction. Hence, it is not well defined. So that is what we mean by step-by-step sequence. And designed to solve a problem, the third thing. So this was the first thing, this was the second thing, this is the third thing. So this is the first thing that is coming from the definition. This is the second thing that is coming from that definition. And designed to solve a problem. Any problem that you are given, how do you solve it? You need an input, you give an output, right? So this becomes your third thing. Solving the problem becomes your third thing. So the input is sometimes given, sometimes not given. You might not be given any input to solve a problem, right? Or sometimes you might be given an input to solve a problem. That is there. So an algorithm, if an algorithm has to be an algorithm, then this line, which is the input line, may or may not be there. So this line is not mandatory line. This line is not a mandatory line, right? It's a dotted line. It may or may not be there. However, the output line always has to be there, which means an output will always be there from an algorithm. Whenever you are given a task, of course you are given a task to produce an output. The task may be given to you without an input, right? So the task may be given to you without an input. Every day in the morning, I will have to take, let's say, tea. That's a task, right? So taking tea is a task for me. So I will produce an output. That is, the output is I have taken the tea. But where is my input, right? I can, of course, debate and say that the tea itself was my input, right? Which can be done. But actually, if you see, if I remove the materialistic nature of this example, if I remove everything in the materialistic world and say that every day in the morning I'll have to meditate, right? Meditation will be done with a purpose. So if I say meditation is an algorithm, then meditation has an outcome that after this I will exit. So that outcome is your output, right? Outcome can be hours. So after 2 hours of meditation, I will stop. So that becomes your output, right? But then did you take any input for meditation? You did not. You just voluntarily started meditating, right? So that way, meditation doesn't have an input. So likewise, there will be so many examples where an algorithm will not need an input to produce an output, right? So that's why input and output is to be treated in this manner. And of course, the last point of your characteristics here is effectiveness of the algorithm. Now, effectiveness of the algorithm, it means that the steps cannot be absurd. Go to the sun and come back. That's not a step that can be practically achieved by a machine or a human. Hence, it has to be an effective set of steps. So those are the 4 characteristics or 5 characteristics that you can remember by marrying that to this definition. So I have tried to marry this to this definition by saying All the keywords of these definition, all the keywords that you see here, finite, step-by-step sequence, instructions designed to solve a problem, are here only. So if you remember the way I'm probably trying to attempt to teach you, then you don't need to probably mark this up. So that's on the algorithm fundamentals, on the definitions of it. And if you have to give an algorithm to somebody, then the person needs to judge your algorithm, right? So the judgment will be on these lines. The person who will take your algorithm and use it for his own benefit will be judging your algorithm on these lines. Time complexity. What is time complexity? Time complexity is how much time it takes to run. How much time, right? Of course, they will ask you how much time. If the algorithm is too costly in terms of time, then they will not buy it from you. How much space will it take, right? So that's also one more avenue that they will have to ask you, that will it be very bulky for me to implement? So that is something that will judge the algorithm. Is the algorithm correct? That is, if I say that, let's say the boundary condition problem that I typically take. Now, if I have to accept, if I have to write an algorithm to accept only 18 to, let's say, 35 years of human beings for, let's say, a drug test, right? A new medicine is going to come to the market, so there is a drug test. Only 18 to 35 people are allowed. I have been asked to write an acceptance algorithm of those 18 to 35 by taking their age, figuring out if it is between 18 and 35, and then allowing it inside. So I will write if age is greater than equal to 18 and age is less than 35, then allow. And this becomes wrong because I missed what? I missed this less than sign, right? So you have missed a boundary condition. So the algorithm is not correct. So what would have happened? 35, the person with age 35 would not have been allowed. But the requirement says 18 to 35 people, it should be allowed, right? So that's where you have done a mistake here. So the correctness of an algorithm is judged by this. Scalability of the algorithm. How do you scale an algorithm? How do you increase the inputs? Increase input and still keep the performance the same. The performance remains same even if your input increases. That's called scalability. Yes, when I say same, it has to be taken with a pinch of salt. It cannot be same, but it cannot be drastically costly for you to actually implement a larger input. So scalable means grow your program by taking more input and doing more of what you are doing. Actually, if you are doing 1 unit of work, start doing 10 units of work, 24 units of work. Do you need to change the code drastically? Then your code is not scalable. That's scalability. Simplicity and maintainability, of course, no brainers. You are not going to be with this code forever in your life. The code that you write will be maintained by somebody for the next 5 years. You will not be maintaining it probably. Somebody else will be maintaining it. And then it will die its natural death. Every code dies its natural death. Right? So the duration of time in which this code is maintained by others should be easy for them. That means the code should be simple and maintainable. You have to write the code in a simple manner. Right? So that's simplicity. Parallelism and concurrency is to actually give you the fact that when you actually execute a code, you'll have to make sure that the entire hardware resources are actually used. So if you have a computer with 4 cores of CPU, then start using all the 4 cores for hungry operations, right? Instead of just siloed into 1 core of operation, you'll have to use all the 4 cores. That means that this will also produce an output, this also produces an output, all these produces an output in parallel, right? So parallelism or multitasking is something that the algorithm should also be capable of doing. All these features, if it actually does, then the judgment will be strong brownie points, right? So judgment will be very high for that algorithm. So that's on the performance features of an algorithm. Now with that we come to the end of this. We are bang on time because for the next 10 minutes what we'll do is we'll take a quiz and then we'll come back into writing algorithms. So let me see if there are any chats. Okay, somebody has already done the row major. So Aman is asking that to reach to the 22nd position from the base address, don't we do 21 into 4? We don't do that, Aman. We said position, we didn't say index, right? So position and index are different, na? So we said we will go to the 22nd position, not 22nd index. So 22nd position will be where? From a 0 index standpoint, 22nd position will be 0 to 21. So we are still skipping how many? 22 records. So 22 records into 4 is what we will have to skip. So that's why the 22nd position is important, Aman. I hope you understand. 4072 and 4044 for row major. Very good. I will need to validate that, Sneha. Okay, Aman, so you have understood it. Very nice. Any other question? Okay, so we were all talking in the chat about the row major and column major. Good. So you have started contributing to it. Nice. Thank you for that. Now let's get into the quiz. But before getting into the quiz, let's do a simple poll. Let me go here. You'll have to give me 30 seconds while I switch windows. Okay, so on your phones, I hope all of you have registered. Please participate in the quiz that is coming up right now. This is a poll and it's typically not a quiz, just one question, just to understand what are your energy levels. Scan this QR code with your mobile. You have already registered, I hope, on the quiz site, and log in. If you can't scan, 228720 is also a typing code that you can give. Good, I see people joining in. We will wait for 120 at least before we start. Come on, rest of you. There are 150 people in the chat. Another 30 seconds. Srijib, no, you don't need to write both of them. You write only one. But mention which one you are writing, 0 or 1. Okay, so since this is the first quiz, I'm giving it some more time for all of you to be accustomed. Oviru Pal, you need to have your profile changed to underscore your university roll number so that I can track it. Alim Ghazi, the same to you. Anik Mandol, same to you. Anit Sen, Anjali Gupta. If you see the screen, all of your friends have given their names with an underscore roll number. Please put an underscore roll number to your name, otherwise I will not be able to track you. Bishwarup Basu, same thing. Disha Karmakar, Farhan Anwar, Jyoti Kumari, Jeet Nandi, Krish Shaha, please put an underscore roll number. Go to your profile and change your last name, change your name or last name, whatever that is called, with that. Please do that before the next quiz. Rafat, Firdaus, Ritam, Jana, Ronnie, Roy, All of you, please do that. And there are so many others also. Pragati Pandey, Gyanshu Raj, please do that. Okay, so we have 120 and I said we'll start at 120. So we'll start this, just one question, just to see your excitement levels. Morning 9 o'clock I asked you to wake up and come for this particular lecture. Obviously the Josh will be sacrificed. Let's see. Okay, I will be ending it now. There are still some 10 of you who have not answered, which is okay. Yeah, almost 10 to 14 of you. Let me end it for the sake of others. Okay, so 3 of you, Josh is sinking. Unfortunate. 12 of you are neutral, very high 66 and high 44. Okay, let's see if we can bring up the neutral and the high people and the sinking people to the very high zone. Let's do a quiz now. So our next quiz is coming up, which is on what we just now understood. Let us see that quiz. So coming up on your screens, a new QR code. Please scan this QR code. Every quiz is different QR code. So just scan that QR code again and log in quickly. And this is a quiz which will contribute to the performance of this course. And as I said, top 1, 2, 3 will be getting goodies from Techno International Newtown. Please log in and answer as fast as you can. It's a fastest finger first. Even if you answer correctly, you might be not the 1, 2, 3. We will wait till 135 logins before we start. $114. Now the rest, guys. Come on, 10 more. Okay, we'll start off. We have almost 130. We'll start off. So as soon as I press the start, The questions will be appearing. I don't know whether I kept 5 or 10 questions. It might be a 5-question quiz or a 10-question quiz. Each of the quizzes is either 5 questions or 10 questions. So please work on the questions as quickly as possible, because even if you are right, you might not hit the leaderboard. Other person might be quicker than you. If you are wrong, of course, you will not get a chance. But then I have seen the tables getting turned very quickly. So if you have answered wrong, don't worry. The person who has answered correctly and is in the leaderboard will suddenly come down. So don't worry about that. So keep on playing it, because the fates will turn very quickly. 134, I'm pressing start. Each question has 30 seconds. Good. 100 of you have answered in 10 seconds, which is nice. Now let's see what the answers are coming. If you have listened to the lecture, you can answer every question correctly. We will end this at 130 responses. I am getting 127 now. So I have 130 responses and I will end the question now. Good. More than 90% is good at any point in time. Shayan Dash is topping it now. Almost 90%. Just now 2 more answered, which brought it down. So 126 people have answered correctly, which means they have listened or they had the knowledge earlier, which is good. So finite sequence of steps to solve a problem is the non-terminating is, why would it be non-terminating? That was one of the conditions of not being it, right? So it has to terminate. So let's move into the next question. Not a performance measure. We talked about some 6-7 performance measures. Good. 10 seconds, 100 of you have answered. Good, good. Keep it up. Chalo, 130, quickly. 150 of you have joined in the quiz. Good. But answer now. Within the next 15 seconds, 10 or more of you answer, please. Let me get one more. Answer at least to get some points, even if it is late, because you never know how the leaderboard will flip. Ending it now. 30 seconds was there. Timer is up. Ending it now. 118. 86 or 85%, I think. Shayan is still topping. Arpan, Arindam, good job. 1, 2, 3. Shayan, Arpan, Arindam. Yeah, 80% almost. Aesthetic design, most of you answered. All the time complexity, correctness and space complexity, the people who have answered might not have seen this word not, because these are actually performance measures of an algorithm, right? So let's move on to the next question. Spelling is wrong, my bad, but anyway it's not the right answer, so don't worry about it. Very easy questions. If you have listened, it is very easy. Just now we have discussed. Come on. 10 more. 10 more answers. Come on, come on, come on. First time we have 140 answers, which is good. I will end the quiz now. 132. See, the leaderboard changed. Preetham Datta, Pratyush Singh. Sayan is still constant. But Arindam Arpan moved down. Probably fastest finger issue. Right? So Preetham has moved up. Good. Pratyush has come up. Good. Their fingers are working faster now. So that's on this particular question. But I'm surprised. Sparse matrix and AVL tree, whoever said. We didn't even discuss that. So we are seeing linear data structure. Things which move in a line. Array and linked list. We discussed that. So next question. Now this will come from your judgment. It might not have been directly told to you right now. I'm just trying to see if you know about it. Most of you might not be answering this correctly. Let's see. Okay, I'm ending the question. Shayan is still there. Preetham, Srijeev has come up. Okay, good. See, Upasana has come up. Arindam has gone down a bit. But we have ample of time. 47% have answered this correctly. And if I see the answers, then these are the correct answers. Sparse matrix is the answer. 0. I don't know how you were typing 0, whether it allowed you to type 0 because there were 6 characters that were needed. But yes, 47% means at least 70 of you know of this batch that a sparse matrix is mostly 0 elements in the matrix. I think there will be a topic which I will discuss about in the next few minutes. But let's move on to the next question quickly. Just now we have done it. I hope all of you answer correctly. 164 of you are here. Can we see 150 responses? Leaderboard is changing very quickly, so don't worry if you are unable to answer correctly in one question. Quickly. After 30 seconds, it becomes a ChatGPT response. At least as far as I am concerned. Okay, I will be closing it off. Let me see if 145 comes up. Ending it. 69%, which is kind of strange. Shayan, Preetham, Arindam, good. Leaderboard is not changing. Based on rows. Column major is not based on rows, Babu. Column major is based on columns. As simple as that. It's aligned with the name. So I don't know where the confusion was. Or was it a typo? Because 20 of you have done that. Please don't do this mistake in your exam. Column major is based on columns. Chalo, next. What is the drawback of arrays? Let me see who gets this correct. Kind of tricky. There will be mixed responses, I know. It was there in the question I discussed, in the answers that were wrong. We selected the correct answer, but we never checked the wrong answers. It was there in the wrong answers. Okay, 145 we will close. We are at 143, 44, 45, closing it. That is good. 72 on this answer is good. Shayan Odindam Upashana, good. So we have requires contiguous memory is the drawback of an array. Of course, it requires contiguous memory is a problem. If we don't have contiguous memory, then it will say no, I can't give you. And that is why linked list is so important, that it can take memory from anywhere and actually do whatever it wants to do. So next question. Non-linear data structure. One question was on linear, now it's on non-linear. Don't confuse. Linear moves in a line, non-linear moves in a network, in a hierarchical manner. .145 is when we will end. So there are 20 of you who are part of this quiz but not responding in time. Don't do that. 78, nice, good. Anything above 70 is taken. Okay, Sayon Orindam Upashana, leaderboard is not changing. Others, buck up. Srijeev, you are doing it late. Geetika, I seen your name at the top. Preetam, you were at the top. Dipendu also, I saw the name at the top. Be quick now. Next. How much memory an algorithm requires? Very simple, very simple. Okay, this took a large amount of time. I don't know why. This was so simple, and that's why my apprehension is most of you might not be getting a good scale on this. 148. Nice. Okay, I'm ending it. 76. Okay, good. That way it is okay. Farhan has been coming up. Okay, Farhan, good. You are at number 6. Top 5 remain the same, I guess. Okay. So space complexity, of course. Time complexity, how much memory? Memory is not time complexity, Babu. Memory is space complexity. Time is time complexity. Right? So next. Why is correctness an important algorithm measure? Quite evident from the answer. What are the rest of the 50 people doing? Come on. 150, good. So 150 answered. Nice. I'll close it off. 71, still okay. Still okay. Nothing changed on the top 5, 6, I think. Ensures minimum time. Correctness doesn't ensure minimum time. Correctness ensures correctness of all valid inputs. So the word correct was already there in the question. But of course you will not get MCQ style questions. So please be careful when you answer this. Don't say minimum time to correctness. Correctness means correct. Simple. Let's move on. It was there in the definition on the 3 things that we talked about. Come on, you can do it. Remember the definition, the 3 things. Two things are already given. Step by step is given. Solve a problem is given. What is not given? Okay, ending it. Okay, Upasana, you went out. Preetham has come up. Srijeev has come up. Okay, good. Answer is finite. I was saying that there are 3 things. 2 things are already given. Step by step is given. Solve a problem is given. So the answer was finite. That's your quiz on what we did just now. So I hope you had fun. And congratulations to the leaders. But they will not be the leaders till whatever period of time. We will see how much or how fast they can be replaced, and it's up to you how you want them to be replaced. This is your class accuracy is at 69%, which is okay, kind of. That is 70% of you are listening to what I am saying. Rest of you are not, so please start listening to what I am saying. You have attended this voluntarily with your own concept of becoming beneficial for your examination. Let's make the maximum use of it. Coming to our next topic. Let me quickly change windows. Give me 30 seconds. Webcam, Windows. Yeah. Okay. So now, if we go up and start about writing algorithms, then writing algorithms is So writing algorithms is about how to write an algorithm and how to probably where is this? 1 minute. One minute, I'm just seeing some haphazard slides. It typically happens when the memory is not keeping up with the pace. So give me a minute. I will probably, all the slides have been haphazard. Give me a minute. I'm just redoing the print and I will come back in 1 minute. Just give me 1 minute. Okay, so this one we will delete. And we will say insert. This. 30 more seconds. Yeah, so sorry about that. Sometimes this happens, and it happened today, which is unfortunate. So algorithms, as I have been telling in my classes, if you have attended my classes, there is no direct or structured way to write algorithms, right? So you can write an algorithm like this, which is on a step-by-step approach, right? Or you can write an approach with a begin-end kind of a concept. Or you can write an approach by just simple English, right? You can just write it in simple English, which is also going to be fine. All you need to take care of is your branching, right? This is all that you need to be careful. Whichever way you do, the branching has to be proper. What are the two kinds of branching? One is if-else branching, another is your loop branching, right? So these two things, for example, they have done the loop like this here. The loop is done like this here. The loop is done like this here. Right, so this is how you need to be. You need to at least read and understand that, okay, I will do this approach. For loops, I will use this kind of a way. Repeat for I equal to 1 to n. Perfectly fine. English, right? It's pseudocode, English, algorithm, all of them remains the same. Right, so remember that branching is very important. Now this will never come as to asking you what is the best way to write an algorithm. This will never come. I am just giving you this, that I have given you 3 styles of writing algorithm. There could be hazaro styles of writing algorithm, right? Only thing you have to remember is, whatever way you write, first of all, English. Don't even worry about anything else. No code, English. And secondly, do not leave the branching concept out of that English. Somehow you have to incorporate that if-else. Somehow you have to incorporate the loop. The way I have shown you here, here, here. So this way, any way you choose, please incorporate that. As long as you are good, as long as it is understandable, it is right. So that is on the algorithm, the way you write it. Now, if we actually move into the concept of writing, let's say, we'll give an example. Let's say string reversal algorithm, right? So if I have to do a string reversal algorithm, then what will we have to do? Let's take a string. Let's take hello as the string, HELLO, right? If this is a string 0, 1, 2, 3, 4, then if I see this from a reversal standpoint, I will have to take this like this. So I will take the first pocket, and the first pocket I will adjust with the last pocket. That is, I will swap with the last pocket. So what I will have here is, I will have O, and then I will have H here. Right, so that is something that I will have, and then I will take the next pocket and I will adjust with this pocket. So then I will have L here, and I will have E here, and this pocket I will have to adjust with itself, right? So I will have L here. So this becomes my reversed string. So how many iterations am I doing? I am doing n by 2 iterations. So I am doing half. I am going till the half, because the rest of the half is getting adjusted along with the first half, right? So I don't need to go to the next half and start adjusting it. That is the key of this particular algorithm. So I hope you understand, we are doing n by 2 iterations here because we have taken the half of the size of this array, and if we can actually replace this half with the rest of the half, then the rest of the half also gets taken care of. Hence we are doing n by 2 iterations. So what we'll do is, let's write the algorithm. So normally I write it like this. I will do a start, and then I'll say input. Yeah, so then I'll say input, let's take a string s of length n. Why n I have to mention? Because I have to now do n by 2. So that's why I have to take a variable which talks about the length of the string. Now I will take 2 pointers. So set 2 pointers, one at 0 and the other, and let's call this as left pointer. Let's call this as a left pointer which is at 0 and a right pointer which is at n-1. Now these are not the standard C pointers, these are pointers to this particular, logical pointers to these particular pockets. That is, one is pointing to the first, so L is pointing here and R is pointing here, right? So R is pointing to n-1. N here is how much? N is 5, because hello is 5 characters. So R is pointing here, L is pointing here. Excellent, fine. Next, what we do? We will repeat while left is actually less than right. So what do we repeat? We will swap S of left with S of right, isn't it? That's what we did here. We swap this S of F with S of right, right? So this is where L is there, S of left with S of right. This swap is what we have to do. So let us do that swap. So we will say swap S of left with S of right. That's all. Don't need to give the swap algorithm. Just write the swap word. It's fine. Increment. Then what? The swapping is done. Then what? Increment. L has to go forward, right? L will go here, right? L will go here. So we will say that L has to go forward and N has to go backward, right? So that's what we will have to say. So increment L by 1, decrement R by 1. So increment L by 1, decrement R by 1 will increment the L to 1 step ahead and decrement R 1 step backwards, which means my first swap is done. Let's do the second swap, right? And how many times we will do this? So this needs to run in a loop, right? So that it actually increments and keeps on incrementing and decrementing. So till the time left is less than right. So repeat till left less than right. This is why we will do it. When left crosses right, there is no point. That is where you will reach half point, right? So half point means left will cross right after that point. So when till the time left is less than right, we will keep on doing this, because left is going like this, right is coming like this. At half point they will meet. We will stop there because left will be less than right. So this is what we will do, and that's all. After this we come out, we will print the reverse string. We will print the reverse string. The reverse string is within S only, because we have changed S only, and then we will stop. So that is your algorithm. Remember, I told you that you have to take care of your branching. This is how I took care of my branching. That's it. I didn't do anything fancy. I just took this, made sure I swap it, move this forward, move this backward, swap it, move this forward, move this backward, and that's what I did till my left crosses right. That's all. That's on the string reversal algorithm. Let's take one more algorithm. Smallest and largest element in a single linear list, right? So smallest and largest element in a single linear list. Okay, a single linear list is like this. Let's say a single linear list is like this: 27, 65, 5, 29, 70, and then let's say we have one more number which is 57. Why did it come in this color? 57, right? So this is my single linear list. It has some elements. Now what is my largest element? 70. What is my smallest element? 5. So write a program to find the smallest and the largest element. So that is the algorithm that we will have to write. So what we'll do is we will say that let's take first that input the number of elements. We can do it in various ways. We can do a hard-coded array. I'm saying that, okay, first give me how many elements you need to be included, which is n, right? And then take those elements in a list. Input those elements in a list. And the list goes on from a 1 ... n. So this is your array that you have taken, right? So this is the A array that I have taken n elements in this A array, right? And of course I missed out on my start. Start is here. Now what we will say is, now we will assume that assume my small that will come out, smallest is the first element and my largest is also the first element. So for the temporary being, I am taking smallest is equal to 27, largest is also 27 to start with, right? I need a number to start with. I'm saying, okay, let's take A1 as the smallest and A1 also as the largest, right? Let us take that and now let us change it in a loop so that we get the correct thing. Now, if my AI, now what is I will run in a loop. So because I have already taken this as my smallest, I can now run I from here. So I can say I is equal to 2, 3, 4, 5, 6. So all these 2, 3, 4, 5, 6 elements we will now compare with the smallest and the largest, right? And then we will see whether they are defeating the smallest and the largest, and then they will become the new smallest and new largest. So we will repeat a loop. We will repeat a loop for I equal to 2 to n, right? We are starting from 2 because this is already done. 27 is already stored somewhere. So we now check the rest of the things, 2, 3, 4, 5, 6. We will now check all of that and we will try to figure out whether they are defeating the smallest and the largest. So we are trying to see if there are defeaters, right? So if A of I is greater than largest, then what happens? This becomes the new largest, then this becomes the new largest. So largest then equal to largest becomes equal to A of I, and if A of I is less than the smallest, then the new smallest is now A of I, and that's it. This loop will go on, and once you come out, you will print the largest and the smallest, and that's how easy this is, right? And then stop. So I hope you understood. There's nothing fancy. This is C code. You have done it so many times. Simple for loop, checking of largest, smallest, assuming things in the first index as the largest or the smallest, and then changing it as we go along the way. Simple thing. Only thing is you have to write an algorithm. So that is what is important here. What is important is how you write this line, right? How you write the repeat line, right? The rest of the things I'm sure you can write it in English the way I explained just now, right? So I think that is understandable. So with that, it's time for us to do one more quiz. Now let's see from a quiz standpoint what we have. Okay, let me go to home, and I'm sharing my screen on that side also, don't worry. Okay, so I see, yes, I will provide you the PDF of the lecture. This entire PPT I will provide you, and this entire PPT would have notes also inside it, so don't worry about that. Let me open the quiz now. Okay, so writing algorithms, let's see how much these are. There are 5 questions in writing algorithms. It will be done quickly. Be ready, be active, answer. Chalo, scan. How many people are live? 137. Okay. Okay, we start at 120. Okay, let's start. 30 seconds, 5 questions, fastest finger first. Okay, let's end it off. Ayush, Shayon, Akib. Good. I see new names. Shayon is still common. Answer is beginning. Some of you made a mistake in the spelling, for which the count is 47, but I can understand that you had the right intentions. But yes, the answer is beginning. So it checks it at the beginning of the loop, which is the right answer. Let's move on. Okay, ending the quiz. Nice, 78%. 1 to 3 doesn't change. Asifur Rahman is coming up. Swastika and Oishani are also coming up. Chris Shaha, you have to change your profile to an underscore roll number, otherwise I will not be able to track you. You are in the leaderboard, but I will not be able to track you without your roll number. So yes, purpose of a step numbering is to maintain clarity and reference. Of course, algorithm doesn't compile. There is nothing called compilation of an algorithm. 10 of you, why you answered that? Algorithm never compiles because it is written in anything, any particular language. Reserved memory, identify variables, I will not probably accept that. Let's move on to the next question. Very simple. Let's see how many of you get it correct. Okay, so 120 at least. 20 of you are not answering in time. Please answer in time. After this we start time complexity. So be quick. 128. Okay, let me end it. 68. Why 68? Leaderboard doesn't change. Okay. Data required to run an algorithm. Memory size. 22 of you answered memory size. Let me see. An algorithm must specify the memory size in the input section. Acha, I now understand what you say. You are trying to think, if it is an array, I have to give the number of elements in that array. But beyond that, you need the data, right? Even if that is correct, I told you, right? In a question, there will be multiple possible correct answers. You have to select the most appropriate. Before even giving the number, you have to give the data first. And then comes the number of that data. Of course, memory size is not something that you are is the way to write it. It would have been the data size of the input element rather than saying memory size. Right? Memory size is for the compiler to figure out, not me, not you as a developer. You will give how many you need. So D cannot be the right answer. Please correct the thought process. I think all of you should get this correct now. Another 15 seconds, I'll close it. Anyone with numeric IDs are automatically disqualified. I need your name _ roll number in your full name column. So go and change it in the profile. I'm ending the quiz now. 67. What is happening? Okay, Upashana has come up. Shayan Akib is still maintaining. Oishani has come up. But what happened? Let me see. It must run on all systems. Come on. Yes, of course it must run on all systems. That is true. But doesn't it? It has no universal syntax is also true. And I have been talking about that, right? Anything which is most appropriate, and most appropriate for an algorithm is the first thing that hits your mind. Should be what? It must run on all systems, or it can be written in any language. Think about it, right? So it can be written in any way, in any manner, in any sense. That's what, when I say pseudocode, algorithm, that's the first thing we always think. Okay, how to write it? Anyway. And then you think about how it must run on all systems. Right, so the most appropriate here is B. Right, so that way I can understand the confusion, but that's okay. Between 99 and 31, we would have hit 80-90%. Last question. Okay, I am ending it right now. Wow, lot of confusion. While, okay, I see the problem. This is my bad. So as you can see, the question repeat until where most of you answered is the right answer, because here you have a while condition and again a do end while. So you cannot have two whiles. So you have while as well as a do, right? So these two are contradicting each other. You cannot have both in one line. Loop, you don't have anything. There is a loop and there is an end, right? So that cannot be an answer also, because there has to be there is nothing called as a loop. First of all, anyway, you can write loop, but then what are you ending? What are you ending is what is important. So loop, and again a condition, and again I mean, what to do with this condition is not what you are mentioning. For example, should I exit after this condition, before this condition? You are not saying that. So that way this cannot be a right answer also. So repeat until condition, right? Until condition of course talks about what condition it needs to match till it becomes false. So the until word here becomes important. So it was a tricky one. Iterate until true, anyway you don't have the condition and the ending point here, right? So there is no end here, that is why this is not correct. But then the correct answer is repeat until. So it's a typo from my side when I created this quiz, that A was marked incorrectly as correct. 42 of you have got it correct. 59 of you who have answered have not got it correct, right? So I will leave it at that, because it will be unfair to either of you to actually make a correction. So probably I'll give it to both of you, A and C, right? So when I actually score you, I'll give it to both of you. Next, that brings us to the end of this quiz. Is there a new leader? Akrit 394477. I don't know who you are. If you are first, you must know your game. Please write in chat window who you are and change your name. Otherwise, this is going to be not counted. Okay, so that's on this particular quiz. Let us move on. Let me see the chat board. Anything here? Shayon is saying while condition, do, end while. So what will that extra do, Shayon? The while condition says that you have to do something. It automatically has the do inside it, na, while. We write a while loop, we can write a while loop in various syntactical languages with just a single while. I don't need a do for that. So that way I would say that while and do are interchangeable in nature, right? So while talks about a condition, which means of course I'm going to do something. So do is inside the while. Sometimes do while is written separately, which is fine, but here do while is not written separately also. While condition, do, end while, that part is okay. End while is okay because you started with while, you are ending with while, but in between that do is creating a challenge here. Again, it is debatable, because if you see the rest of the responses, the repeat was more obvious. So as I said, please select the most obvious. Next, there is a glitch. It is showing me as third. I think the web is giving priority to caps and numbers. Okay, so you are saying that you are the numbered person, 39477 Zeniki, right? So if that is the case, then I think you'll have to change your last name. You have not changed your profile last name. Please go ahead and change it, otherwise it will show up like that. It's a random name that it has taken as your username. Because the report that I will get is the exact username that you have typed, not whatever I see on the screen right now. Okay, so whoever was the winner in this quiz, I don't know who it was, please change your name. I will quickly move on. I hope you understand what I am saying. I will not waste time there. All I am saying is please change the name to last name, whoever's name is showing up as a number. It is impossible that the name is same. It's not a number, but it is showing up as a number. It's impossible on that standpoint. Let's move on to time complexity quickly. We have two more things to do before we break off. Time complexity and asymptotic. So let's quickly finish them off. Now I am trying to bring this here. Yeah. Okay, so this is what we start. This is an important topic. All of you would have gone through this, might have understood it, might not have understood it. Let's make an attempt to see if we can make a better understanding of what we know. So time complexity is about two things. Just remember two things: time and order. These are the only two things from a time complexity standpoint that is measured. So when I say time complexity, we will be measuring these two, or we will be talking about these two. When I say space complexity, we will be talking about space and order. These two, as simple as that. So when I say that I have given you a code where if I increase the number of inputs, let's say I increase this number of inputs like this. So input size is n. I'm increasing the number of inputs. Is the actual time to execute the code changing here? The actual time is not changing as we increase the number of inputs, right? So what is happening? The program is running in a constant time, irrespective of the input size, which is okay. Okay, so that is one point. Hold it on your thoughts. Time is not changing because of inputs increasing, which is quite obvious. It should have changed. It is not changing. Fine, perfectly fine. Let us say that if that is the situation, then if I take this same code, this is my machine. If I take this same code and execute in my friend's machine, and his machine is a bit faster, or it's a bit slower rather, it's a bit slower than my machine. So his machine will take a larger amount of time to execute. I took 0.5 seconds to execute, irrespective of my n. His machine is taking 2 seconds to execute, irrespective of the n. So his machine is taking this amount of time. Does my algorithm change? My algorithm doesn't change. I just ported my algorithm to his machine. My code remains the same. So the point that my algorithm is running slow should not be penalized on me. It should be penalized on his machine. My code was proper. If somebody wants to buy my code, will he be considered about that it is taking slower time in that machine? He will say, okay, he has a faulty machine. I have a better machine. I will run it better. Give me your code. So he will be happy even seeing this, and even seeing one more machine which was much more slower than this machine. So that took 3 seconds to execute the same piece of code. Even if the input changes, nothing changed. So there are two things we are talking here. With the change of input, the time remains constant, right? With the change of input, the time remains constant, and the time which varies from a slower machine to a standard machine to a faster machine, right, does not matter. Does not matter to whom? Does not matter to the purchaser of your algorithm. He says, I don't care. I don't care about the machine, because whatever machine I will produce, I know that it will perform according to the machine. Your code's performance is not that. Your code's performance is not 2 seconds or 3 seconds. Your code's performance is what? Your code's performance is two things. One, it remains, time is constant, right? So whatever time it is constant, either this constant or this constant or this constant. Whatever time it is, wherever you execute, it will always take that amount of time. So that's your code's feature, that your code takes always constant amount of time. I don't care about how much time, the value I don't care. I only care about the fact that it is constant. And the second thing that I care about is that it is linear. It is linear. Linear means, of course, if it is constant, it has to be linear. In another example, I will show you how linear also matters. But remember these two things, that if the time is constant and if it is linear in nature, then you are actually hitting a stage where you are saying that my time complexity of this particular problem is something that I can say that, okay, my actual time taken, I told you right here, we will be talking about two things. One on the time and the other on the order, right? So I said we will talk about these two things. So on the time, if we talk, then the time is constant. So how do we represent a constant time? A constant time, if we have to represent to somebody, right? We cannot say that it will take 3 seconds on this particular machine, 2 seconds on this particular machine, 5 seconds on this particular machine. I cannot say that. That becomes too cumbersome. Then we have to give the machine configuration, we have to give the RAM, we have to give the CPU, blah blah. Right? So instead of that, we say that whatever is the machine, it will take constant amount of time. So constant amount of time means order of 1. So now we start talking order, Tn. Tn becomes order of 1. So theoretical complexity or asymptotic complexity, as we call it, is the order of complexity. That is, what is the order of time? What is the order of time is what it is asking. What is the actual time is not what it is asking. Actual time is variable, but the order of time is constant, right? Constant means order of 1. So we cannot express order of a constant by any other way, because order of 1 is saying that I will take 1 unit of time in your machines per unit game. So if X is your per instruction unit of time, then I will take 1 multiplied by X. So if you execute instructions at X for a unit of statement that is given to you, then the entire code will finish in 1 multiplied by X. That is what 1 is trying to say, right? So it says that 1 unit of time. Now that's where we will actually say that the steps or operations or the theoretical complexity order of 1 is represented like this with n. So if on the right side we are talking, here we are talking about time, and here we are talking about order, right? So that is the two difference that we are trying to say. So time being constant means order will always be 1. Order cannot be variable because order is not varying here, right? Order with input is not varying. So I cannot mention that my order is a function of n. While I said here Tn, but Tn means that time is a function of n, but when I see order, I don't see n here. That means this order is not variable with n, and hence it is a constant time. So that is what I can deduce. A person who sees order of 1 knows that with input it will not vary. That is what we are trying to say here. With input, this time will not vary. That's why n is absent. N is absent here. N is not here, right? So that's why we have to eliminate m. What do we write then? We write order of 1. 1 to signify that we have 1 unit of the steps that we will execute. Whatever time those steps will take, we will take always that 1 unit of step. So if a faster machine takes, let's say that 1 unit, this X in a faster machine is 0.3 seconds, then I will execute this in 1 into 0.3. If there is a fastest machine which is 0.1 second, then I will execute it in 1 into 0.1. So 0.1 seconds will be my actual time. So the time will vary. We know that, but the multiplication factor will be 1, and that is where the order of 1 is coming, right? So I hope you have understood what I am trying to say. So if we actually talk about a similar problem from a complexity standpoint, then think about this. Let us say there is an array which is, let me wipe out this for the sake of better clarity. Yeah. So let me say that I have an array. Okay, I have an array like this, and I have these 4 pockets. Let's say this is at 4000, and this is 0th index, 1th index, 2th index, 3th index, and in this array I have let's say 7, 8, 5, 2, and I want to access this particular element. We all know we can access it by saying ARR of 1. What is it internally treated as? What does it internally get translated to? It internally gets translated to star of ARR plus 1. What does that mean? The name of the array is the starting address of the array. So that means star of 4000. The name of the array is the starting address of the array, right? So star of 4000 plus 1 unit, 1 block. 1 block is how many bytes here? Integer, right? So 1 block is 4 bytes, right? So star of 4000 plus 1 means star of 4004, right? So with that I hit this particular element which is at 4004. This element is at 4008, and the last element is at 4012, right? So if I have to hit the last element, how will I write it? ARR of 3. What is ARR of 3? Star of ARR plus 3. What is star of ARR plus 3? It is star of ARR means the address of the first index, which is 4000 plus 3 blocks, which means star of 4000 plus 3 into 4, which means 12. Why 4? Integer is 4 bytes. 3 blocks of integers. So star of 4012. So which means that go to this particular address, and this address has this, right? So what do you see here? When I use this index, this is called indexed method of addressing, and this style is called as direct addressing. Directly I have the pointer, I am addressing it like that. Now which one will take more, or which one, let's talk about between these two, which one will be costly? ARR 1 is costly or ARR 3 is costly? Then we'll talk about indexed versus direct. So ARR 1 is costly or ARR 3 is costly? Which is costly? Let me see some chat inputs on this. Cam is off. Okay. Okay, while I fix the cam, please talk about the question that I asked. Which is costly? ARR 1 is costly or ARR 3 is costly? Or are they the same? Are they both the same? Please answer. I'll fix the cam and come back in 30 seconds. Let me see if you have answered. Same, no, same, both, both same. Okay, good. Now whoever is saying ARR 3 is costly, they are thinking that we have to go a farther distance. We have to go here, right? This is your ARR 0, 1, 2. In fact, we have to go here. So you might be thinking that we are going at the last end of the array and hence it will be costly. Actually no, because we are not going like this. We are going directly. Right? So we are going directly here. And why we are going directly is because of this indexed and to pointer address that I talked about. So we will directly take this pointer star 4004. We will go here, or we will go here, or we will go here. I don't need to traverse like this. I have the actual address here. See, I calculated the actual address. I will directly go there. I will directly go here. This is here, and this is here. I'll directly go there. Like this, I'll calculate and go. Do I need to traverse through all of this to go to the last element? No. So that's why ARR 3 is not the right answer, and hence the answer to this search complexity for addressing array through direct addressing based is the same. It is going to be the same. So ARR, search complexity of addressing. They are asking what is the search complexity. So that means that if I actually address ARR 1, if I want to search for ARR 1, I will take X amount of time. If I want to search for ARR 3, I will also take X amount of time. Because I got the actual address, I will go to that actual address and I will get that data. Right? So if you understand what I'm saying, then this X and this X being the same, what does it mean? To access an element of an array, I need constant amount of time. First element same time, second element also same time, fifth element also same time, nth element also same time. To access an element I need a constant time. See, this graph is coming. To access an element I need a constant time. Irrespective of the input size, I need a constant time. Irrespective of the input size, whichever, give me any array, I will take the same amount of time to reach an element. That's what I'm saying. I'll take the same amount of time because I'm not going to go by this. I'll go direct by this logic. Right? So that's what I've tried to explain, which means that if it is a constant amount of time, it will be an order of 1 kind of a complexity. Hence the answer to this problem is order of 1. So I hope you are able to understand this. Next, we'll talk about order of n. Similar concept. It's just that now we are saying that instead of with input the time remaining constant, we are saying the time changes, time changes, time changes. Right? So that's what we are saying. We are saying that it will change. Now, let's say this is my machine, which is fastest. The time changes like this. In my friend's machine, the time changes like this. It takes a bit more, right? See, it goes till here 7.5 till 17.5 units will take 7.5 seconds or milliseconds. And in the slowest machine, it might take 18 seconds for 17.5, right? So what does this mean? It means that again the same thing. One, the time taken is increasing with n. That is what the first meaning is. And the second thing is the increase is in a linear manner. Again, the linear concept that I told you in the last slide, this becomes important here. In the last slide, I said time is constant with n in a linear manner. Here I am saying time is increasing with n in a linear manner. Right? Why the linear manner is important? Because if I draw a curve like this, time is increasing, but not in a linear manner. So this is not the same, this curve is not the same as this curve, the red curve. Right? They are different curves. But these three curves, when they are plotted from a time axis standpoint, they represent the actual time. And the actual time differs on different machines for that algorithm. So this algorithm, which is algo 1, this algorithm is also algo 1, this algorithm is also algo 1. Just because the machines are different, their slopes are different. And because their slopes are different, what can we conclude about this slope? What is this? I said it's a linear manner, means it's a line. If it's a line, can we talk about y equal to mx plus c? This is the standard equation that you know about a line. Right? If y equal to mx plus c, m is your slope and c is your intercept with the y-axis. Here the intercept is 0. So here c is 0. Right? Only thing you have is a particular value of slope. With time, if I plot this and say that n, if I replace y with time and x with n, then this becomes y equal to mn. Right? So with this becomes y equal to mn. So my time taken is a multiplying factor, which is the slope multiplied by n. And I can also say that, okay, if the time taken is actually having an intercept, then let me say that time is equal to mn plus c. I can also say that if it has an intercept. So time is equal to mn plus c. N is what? N is the number of inputs. N is the number of inputs. T is what? The time taken. Actual time taken. I'm talking about this time, not talking about the order. I'm talking about the time. So the time taken will be calculated like this for any linear curve. If that is the case, whatever is the highest degree of that polynomial becomes the time complexity or the asymptotic complexity of that polynomial. So what does that mean? It means that the highest degree of n in this is 1. T equal to mn plus c has m raised to the power of 1. There could have been an equation as t equal to, let's say, n square plus bn plus c. In this case, the highest degree of this polynomial is 2. Then the time complexity, which is the asymptotic complexity, this is the actual time, don't confuse, this is the value, the amount of time, the milliseconds of time. But when you say order, you will not say the actual time, because the actual time is dependent on the machine. If you want to generalize it into an order, then we will say that time taken will be an order of the highest degree. So in our case, we will say n, and in this case, we would have said time taken will be an order of n square. So that is this particular example where we talked about an order of n, right? So if we take an example of the similar lines, an order of n, then let's talk about our bubble sort. What is a bubble sort? Bubble sort will take this whatever example. I already have an example. Let me remove this. Let's talk about the example here. It says, what is the best case time complexity of bubble sort? Best case time complexity means that the sorting is already there. I don't need to do anything, right? If the sorting is already there, I don't need to do anything. That is my best case, right? So this is sorted, right? See, every element is sorted. So if I give this to bubble sort, will bubble sort immediately come out and say everything is done? It will not, because it doesn't know it is sorted. It will have to painfully go through all the elements to understand it is sorted, which means it will at least have to do one iteration. So it will at least have to say that I will compare this with this and see that this is in the right place. Then I will compare this with this and see this is in the right place. Then I will compare this with this, see that this is in the right place. Then I'll compare this with this is in the right place, and so on and so forth. If I do this, then how many comparisons have I done? I have done one comparison here, two comparisons here, 3 here, 4 here, 5 here, 6 here. How many elements did I have? I had 7 elements. How many comparisons did I do? I did 6 comparisons. So basically I did comparisons is equal to n minus 1. So I have done n minus 1 comparisons. So n minus 1 is the amount of time I will take for every bubble sort program will take to actually say that the sorted array is a sorted array. So giving it a sorted array, still for it to say that it is a sorted array, it will do one iteration and check everybody is in the same place, and therefore it did not make any swaps. If it doesn't make any swap, it will understand the array is sorted and exit. That means one iteration to lagega hi lagega to understand if everybody is sorted, and in that there will be no swaps, and hence it will be treated as in the same place, right? So that is on this particular example, which tries to say that the n minus 1 is going to be the cost of actually seeing, even in the best case, how much of the time it will need actually to solve this best case problem. So that's on this. But then how do you write the complexity for that? N minus 1 is my time taken, right? So let's put n minus 1 into our generic equation format. So if n minus 1 is the time taken, where are we? Yeah. So if n minus 1 is our time taken, then the time taken we are saying is n minus 1. Right? If time taken is n minus 1, that means that n minus 1 multiplied by some time will be taking n minus 1 multiplied by some time. Now what is that some time? N minus 1 times we will do this swap operation. This swap operation takes, let's say, p amount of time. This swap operation takes p amount of time, right? Or for that matter, let us say that it is a constant c, right? Let us say that it is, of course it is a constant for that particular machine, so it will take a constant amount of multiplier. So this swap will take c amount of time, and n minus 1 swaps or swap checks will be needed. When I say swap, I meant swap check. The swap check will be taking c amount of time, and n minus 1 swap checks will be done. So this is my total time. All of you would agree to this. So then how can we represent this as an equation? We can represent this as nc minus c. nc minus c. Is it in the form of y equal to mx plus c? Of course it is. Why? Because this m here is this c, right? So this m here is this c, the x is your n, and this c is your this c, right? So that is how this particular equation translates to y equal to mx plus c. So if I rewrite this equation in a y equal to mx plus c format, then this will look like this. My time t is equal to y equal to mx. What is my m? C. What is my x? N. And what is my c? C. So this is what it is. This is in the format of y equal to mx plus c, where this is m, this is n, and this is c. Right? And then if this is the equation, then what is the time complexity? This is a linear polynomial. Highest degree of n is 1. Therefore, the order of this particular polynomial will be order of n. N has the highest degree of the power of whatever that variable is, whichever that either x or n or whatever that variable is, the dependent variable, right? So then that becomes the time complexity for this particular example, right? So bubble sort, if it actually comes and tries to follow this particular line of complexity, right, it will always translate to an order of n. Right, so anybody who is following y equal to mx plus c, irrespective of the value of m or c. Why? Because m's value is because of the hardware, na? M becomes steep or m becomes slanted is because of the hardware. I don't care about that. So all these y equal to mx plus c's are the same to me. If they are same, how do I represent them as one single unit? I will talk about their asymptotic complexity or order. Order of time of there will be the highest degree of that polynomial. Highest degree of that polynomial is x to the power 1. So it will be order of x to the order of x, right? Or order of n in our case, because our case x is equal to n, right? So I hope you understand order of n from this particular example. And this is a question that has come. So asymptotically you have to write Tn is equal to On. So even if it took n minus 1 comparison, see that asymptotically you are getting n. So you are not getting n minus 1 as your order of n minus 1. Right? So order of n minus 1 is not what is the answer, though you are doing n minus 1 comparisons. First of all, two reasons. One, asymptotic complexity is always for large values of n. It is never calculated for small values of n. So in a large value of n, minus 1 doesn't have any significance. So minus 1, n minus 1 means the same as n. That is first point. Second point is, and if a time is of the complexity of the, if the time has a value of n minus 1, then I can of course represent it as y equal to mx plus c. This is the dependent variable, and in fact this is the dependent variable, and this is the independent variable n. So when I say x is my independent variable, y is my dependent variable, it follows the same format, n minus 1. What is my slope here? Slope is 1, m is 1, and then x is equal to n, and then we have minus 1 as my c. So if this is y equal to mx plus c, then I can definitely say that the time will be, order of time will be, or order of complexity will be the highest degree of this particular n. In our case, the highest degree is 1. So order of n will be the complexity. So that's why n minus 1 doesn't mean it becomes n minus 1. N minus 1 is also n. N minus 20 is also n. N minus 200 is also n. N minus 2000 is also n. Likewise, 12 is also order of 1. Where is my mouse? Yeah. So 12 is also order of 1. 15 is also order of 1. 200 is also order of 1, and 1000 is also order of 1, because all of them are actually constant amount of time. So constant means order of 1. So I hope this concept is getting clearer as we go along the way. Let us take some examples now. Now if I take this example, then yeah, so if I take this example, then my if we think about how much time will be taken to assign p equal to 100, will it be a constant time? I don't care about the amount of time. I want to see whether it is constant or variable. And if it is variable, how does it vary? Does it vary linearly? Does it vary quadratically? Does it vary cubically? Does it vary logarithmically? Does it vary exponentially? I hope you are getting what I am going. I am saying that okay, constant means it does not depend on n. Variable means it depends on n. But depends on n can be so many things, right? So I need to know those in order to give the order, right? So when I say p equal to 1000, I will say that this never changes This will always take constant amount of time in every machine. In machine number 1, it will take 200 milliseconds. In machine number 3, it might take 300 milliseconds. In machine number 7, it might take 100 milliseconds. So what? In machine number 1, if I run it 1000 times, it will always take 200 milliseconds. In machine number 3, if I run it 5000 times, it will always take 300 milliseconds. So whatever is the number of times you run, it will always be constant. The time does not matter. Time is dependent on the hardware. Hence, this is order of 1. So this will be classified as an order of 1. R equal to 5, same concept, it will be an order of 1. T equal to 2, it will be an order of 1. There is nothing that changes with input. This doesn't change with input. This is also an order of 1. Right? It might be a larger calculation, larger amount of time, but it is always going to be a constant line. It is always going to be a constant line with the x-axis. If it is a constant line with the x-axis, you know it is order of 1. If it is a slopey line, a line with a linear slope, then you know it is order of n. These two things you already know by now. So this one will be also order of 1, because there is nothing that is changing in the input to justify that this will follow this particular curve. N is not influencing the time here. Sorry, n is influencing the time here, but n is not influencing the time here. In none of these, n is influencing the time. So what is my total time complexity coming to be? 5 times the order of 1. Right? So 5 times order of 1 means what? It is still order of 1. Right? 5 times order of 1 is still order of 1. Why? For example, I will just explain. So let's say this takes 200 milliseconds. This takes 100 milliseconds. This takes 100 milliseconds. This takes 200 milliseconds. This takes 100 milliseconds. What is my total time taken? 200 plus 100, 300, 400, 500, 600, 700. So 700 milliseconds is the time that I take to execute this particular problem. If I run it 5,000 times, will I take 700 milliseconds every time? Yes, we will take. Because my hardware is the same. 7,000 times I run it, 17,000 times I run it, 1,17,000 times I run it, it will still take 700 milliseconds. Now what does that mean? The line curve, that if I draw, the line curve will look like 700 milliseconds here, and my n going this side, my time going this side. What is this line representing? It represents an order of 1, because it's a constant line with no change. Hence 5 times order of 1 is also order of 1. 700 milliseconds is also order of 1. I hope I have been able to clarify this concept to you. Next, we take an example of order of n. Now this line, in order to execute, don't mistake yourself by saying that this line takes n, because there could be n elements in the worst case here. Yes, there could be n elements, but we are not looping through these n elements. We are not taking one element at a time. This is one single shot assignment. One single shot assignment is always order of 1. N equal to 5 assignment, no changes with n, order of 1. This order of 1. Now this for loop, be careful. I equal to 0. I equal to 0 means what? First it will do I equal to 0. Second it will do what? It will check this condition, and third it will increment it once the loop is entirely over, right? So what will happen is, for I equal to 0, that I equal to 0, this particular line will be executed in an order of 1, because this is only going to happen one time in a for loop. The first initialization happens only one time, which all of you know. Since it happens only one time, I am saying order of 1. Now I less than n will happen how many times? Let us take an example. Here the example is already there. So let's say the count, and let's say that n. Now if my, or rather why take count, we already have I. We already have no n, right? So now what we know is I is at 0 and n is at 5. What are we checking? We are checking I less than n. Now is I less than n true? Yes. So then we will do an I plus plus, right? So if we do an I plus plus here, then I becomes 1. This 1 comes to the next iteration, and then we have 5 here. I less than n is true. I plus plus is taking it to 2. 2, 5, true. It is going to 3. 3, 5 true, it is going to 4. 4, 5 true, it is going to 5. 5, 5 false. Right? 5, 5 false. So what do we have here? How many iterations or how many checks of I less than n was done? If you see carefully, then we did the first check here. 0 is less than 5. We did one check here. Right? So this is one check. This is the second check. This is the third check. This is the fourth check. This is the fifth check. And then one false check is also done. So how many checks we are doing here? When we are doing these checks, we are actually doing n minus 1 checks, right? So let me put this as unit of time, okay, instead of order. Then it will be easier for you to understand. So instead of order, I am putting unit of time. Let's say 1 unit of time, right? So instead of putting the actual milliseconds, I will say 1 unit of time, 1 unit of time, 1 unit of time, 1 unit of time. Then we will say this is as this one is also 1 unit of time, and this one we will say as n plus 1 unit of time, because we are doing it 6 times, na? And our n was 5. So how many times did we compare? N plus 1 times. So if n plus 1 times we compared, then n plus 1 times comparison is let's say budgeted here. Now I plus plus will be done how many times? See, I plus plus was done 1 time, 2, 3, 4, 5 times. So I plus plus was done n times. So this is n unit of time. I hope you understand unit of time concept, right? If it is not clear, this takes 1 unit of time, right? So whatever is the unit of time taken to actually initialize an array will be multiplied by that to get the actual time. So I am just saying 1 unit of time, right? I don't know this, I don't care about this, because this depends on the hardware. That's all I'm saying. So 1 unit of time. With that, I hope that is clear. So then this becomes 1, n plus 1 and n. So the 3 syntaxes of the for loop, this and this, take this amount of complexity. And if anything executes itself n times, then all the things inside it will execute n times. If a loop executes it n times, everything inside will execute n times. So ideally speaking, this should execute n time, this line should execute n times, this line should execute n times. N times in the sense n unit of time. So n times it will go multiplied by 1 unit of running that syntax, right? So then we will say that ARRI target will execute n unit of time. This should also execute n unit of time, but then this exits, right? See, this exits. So I will take the best case here. I'll take the best case and say that probably it exists in the first iteration itself. In that, this printf will execute only once, 1 unit of time, right? So this will also execute only once, 1 multiplied by the unit of time, right? So 1 multiplied by the unit of time. So then how does this come to, or what does this come to? This comes to, let's say 1 plus 1 plus 1 plus 1 4 plus 1 5 plus 1 6 plus 1 7, 7 plus 1 n plus n 2n plus 3n. So 7 plus 3n. Now can I write this as time taken therefore is equal to 3n plus 7? If 3n plus 7 is like this, can I say this is equal to mx plus c? I can, where m is 3 and 7 is c. So then am I talking about a line like this? Yes, I'm talking about a line like this, where n is this side and time is this side, and I'm getting 3n plus 7. So if 3n plus 7 is coming, then I know that if a line is y equal to mx plus c, the order of complexity that I can represent is equal to the order of the highest degree of that polynomial. Highest degree of the polynomial is n to the power 1. So n, right? So that is what I will represent as the time complexity for this particular algorithm. So I hope that makes it clear. One more algorithm let's do for order of n square. Right? So order of n square is going to be simple. Now if you see here, we said that this particular line takes order of 1. Right? So this particular line takes an order of n plus 1, and this particular line takes an order of not order, unit, right? So unit of n times. So if I add these 3 together, what does it come to? It comes to n plus 2n plus 2. It comes to 2n plus 2. Now what is 2n plus 2? Is it y equal to mx plus c? Of course it is. Where this is my m and this is my c. So then this particular, these three statements are executing in a y equal to mx plus c kind of time. So time is here, n is here. So this is actually 2n plus 2 line. So then if this executes as a line with a linear slope, then my time complexity is the highest degree of that particular polynomial. So it becomes equal to what? Time complexity becomes equal to order of n. Right? So this particular line, this any for loop for that matter, where you see that there is a increment that is linear in nature, not non-linear. Like I am not saying I star equal to 2. This is a non-linear increment. Or I slash equal to 2. This is a non-linear increment. When you have a linear increment like this, you can blindly say that this will be an order of n. Just now I established, right, that 2n plus 2 is nothing but n. 2n plus 2 is nothing but n. That's what I established just now. So we, for all practical purposes, we will take this as n now. So if this is n, then everything inside will be executing with an order of n. Right? So this will be order of n execution. This will be an order of n execution. This will be an order of n execution. N units of time it will take. N multiplied by that syntax is unit time. Right? So anything, any for loop that takes n will mean everything inside will also run n number of times. That is why it takes n. Everything inside runs n times. Now if that is understood, now we are moving into this loop, and this loop also takes n, because this is also a for loop with a linear increment. So this loop also takes n. So if this loop also takes n, anything inside will also take order of n. Anything inside means these two are inside this inner for loop, so they also take n. Why? Because this gentleman takes n. So then what do you get? You get n square, n square, n square. That means 3n square plus n. This is what you get. Y equal to, or t equal to 3n square plus n. T equal to 3n square plus n. Can it be classified as y equal to ax square plus bx plus c? I can do that. Why? Because then this 3 becomes equal to a, and 1 is anyway here. 1n, I can assume 1n as n. So then 1 becomes equal to b, and I can assume 0 here. 0 becomes equal to c. Right? So 3n square plus 1n plus 0 is ax square plus bx plus c. So 3n square plus 1n plus 0 being ax square plus bx plus c means that it is mirroring what? A quadratic class. A quadratic class of polynomials. So this quadratic class of polynomial will mean that the graph will look like this. The graph will look like this with n, and it also means that the order of complexity of a quadratic polynomial will be the highest degree, which is 2. That means order of n square. So it is varying with n, but with what variance? Linear variance or quadratic variance or logarithmic variance? With n it varies, we understand. But with what variance? That is what this is trying to tell you now. That with quadratic variance is what this polynomial or this equation will vary. I hope this is becoming clearer. Next, we'll see a difficult calculation in terms of logarithm. I won't say difficult. I will say that it is more of a different way of calculating the complexity, because you don't have access or you don't know how the particular loop variable will change for you. Right? So if I say that I have this particular example, and whatever is the situation, right? I will not consider this for now. I'll come to you why I am not considering this. But can I say that this is a for loop? Yes, I can say this is a for loop. Can I say this has order of n? Just now we have said that all for loops will have order of n. But then I gave a caveat. I said provided provided, when I calculated it here, yeah, this one, I said provided this is linearly increasing or linearly decreasing, linearly increasing or decreasing. But that is not the case here. This is a for loop, yes, but this is not linearly increasing or decreasing. You have value less than n, but value changes 2 times. You are doubling the money every day. So the value changes 2 times every day. Right? So how many times this will execute? You don't know. You can't say n times it will execute. N times this loop will execute, right? So what you will need to therefore say is, we'll need to calculate them. That's the only solution. So let us take count. Let us take value, because we have value here. Then after value we have value is compared with n. And then we have, let's say, value star equal to 2. Right? So here, if I say the first time it enters, the value of value is 1. Now is value less than n? 1 is less than 1000, right? Which is true. 1 is less than 1000 is true. Okay. Then the value star 2 is 2, because value was 1. I will make value star 2 equal to 2. I'll move into the second iteration with this same value that I got here, right? And I'll check this value with 1000. I'll get true, and I'll make this value as 4, because value star 2 now becomes 4. How do I write 4 differently? Let me write 4 differently. So I will write 4 as 2 multiplied by 2, right? So that is how I did the last value multiplied by 2. Then I will run my third iteration. So this will be a value of 4, and with this 4 I will see that 4 is less than 1000, and then I will make this, mark this as true again. The check is true, and this will be 2 into 2 into 2, right? So this is how the value into 2 will actually increment it. What about the next iteration? The value will become 8, right? So 2 into 2 into 2 is 8. So I start with 8. 8 is less than 1000. Yes, true. And then I say that 2 into 2 into 2 into 2. So this is what I will say. Now, is there a pattern that we can see? Now what I want is, I want to see that this value, which is saying that I am actually increasing myself, right, and I will go till 1000, will influence the number of times this count actually happens. So what I mean is, in the kth iteration, or can I take this 2 and influence this value with this count? Then my job is over. Why? Because I want to, my original intention was to know what is my count as a function of the number of times that this particular program will execute, right? So the program will execute how many number of times, I don't know, and I know that this count will take me somewhere. That is the count that the program executes, right? Let us say that that count is k. Let us say that the program executes till the kth iteration, and till the kth iteration, if I execute this program, then can I say that this 2 is 2 to the power 1? How am I correlating? I am correlating like this. This 1 I am taking from here, right? And here I am saying 2 to the power 2. Here I am saying 2 to the power 3. Here I am saying 2 to the power 4. All these I am taking from the count. So I am saying that value increment will be, the new value will be actually equal to the number of iterations, 2 to the power the number of iterations. So can I say that for the kth iteration it will be 2 to the power k? Of course I can say. So the value will be 2 to the power k at the kth iteration. At the fourth iteration, if the value is 2 to the power 4, then at the kth iteration the value will be 2 to the power k. I hope this you can understand. So if the value is 2 to the power k, then my k, the count of the number of the value that we have, that is, let's write value as 2 to the power k. Now value can be greater than equal to n? No, it cannot be greater than equal to n. Value will be always less than n. N is 10,000, or rather 1000 here. So value is greater than n, always, sorry, less than n, which means the program exits here. This is the exit condition. If this is the exit condition, then can I say this is what is the value, right? At a kth iteration, this is the value. So 2 to the power k also will exit at n. So if the value at the kth iteration is 2 to the power k, then 2 to the power k will exit at greater than equal to n. right? So if k is at the last iteration, so let's say this is at the last iteration, or it has crossed the iteration, that is in the boundary of crossing, then because of k, the value would be 2 to the power k, and 2 to the power k will be crossing 1000, right? So that is what I'm trying to write here. Because of this k, 2 to the power k will be crossing 1000. That is what I'm trying to write here. So 2 to the power k is greater than equal to n is my exit point, which means I can write this as the exit happens at 2 to the power k equal to n. Instead of greater than equal to, I say equal to n, right? So if 2 to the power k equal to n is the exit point, then how do I represent this? How do I bring out k? If I want to bring out k, because my goal is to find out how many counts. That is what I want to find out. Na? I want to find out how many times it executes. That will give me the order. So my goal is to find out this k, which is hovering around this boundary of 10,000, because k, the number of times k goes, value increases 2 times, right? So k goes to what level when the value becomes 1000 is what I'm trying to see. So k goes to what level? So k becomes 2 to the power k goes to when k goes to what level means k will go to such a level that 2 to the power k will become 1000, right? So that is what we have been trying to say, that k goes to such a level that 2 to the power k becomes equal to n, equal to 1000. So k becomes equal to log base 2 of n. If you take log on both sides, k becomes equal to log base 2 of n. So that is how you get log base 2 of n as the number of times you will execute this program in order to get to wherever you want it to be. That is, you wanted to understand how many times this program will execute. It will execute k times, because you don't know how many times. You said it will execute k times. You found out a pattern that if it executes 4 times, then the count goes to, the value goes to 2 to the power 4. So if it executes k times, the value will go to 2 to the power k. So if k is the last iteration, 2 to the power k will be equal to 1000. Right? So 2 to the power k will be equal to n. If 2 to the power k equal to n and k is the last iteration, then k's value is what? Log base 2 of n. And that's why you get log base 2 of n as the order of this particular equation or this particular problem statement. So that's how log base 2 of n is coming from this particular problem statement. If we move on to the last problem statement, this is a root over n complexity. So root over n complexity is something that comes out from this particular code. In root over n complexity, what you will see is, again, you see pages is dependent on n, pages is incremented based on I, and I is incremented here, all hodgepodge. If it is all hodgepodge like this, then you cannot say this is order of n. Sir said for loop is always order of n. I never said for loop is order of n. I said for loop is order of n if it increments, if I increments in a linear manner or I decrements in a linear manner, right? So that's what I said here. No linearness is there. So this cannot be an order of n, right? So let us remove this. This is not an order of n. So what is this? Again, we will do the same concept. So let us take a count to find out how many times we are wanting to find out how many times. So this is what we find to find out how many times it will go. Let us take I because it appears there, and then it compares with pages less than equal to n. Okay, and then we have pages plus equal to I. Why? Because this will happen first and then this will happen, right? So the for loop will execute itself and then the last iteration or the last statement in the for loop will be executed, which is on the top of it, right? So this will be I plus plus will be executed here. Okay, so now that's my dry run. So in my dry run, if I now say that count is equal to 1, the first iteration, I's value is 1, pages is less than equal to n. So pages is what? 0. 0 is less than equal to n. That is true. Whatever that n is, n could be a large number. Right? So 0 is less than equal to n. Pages plus equal to I. So pages plus equal to I will be 0 plus 1. And I plus plus will be 2. So which is fine. Now second iteration I start, my I's value is 2. So 1 is my pages. My pages is 1. Yes, my pages here is 1. So 1 is less than equal to n, which is okay. Then pages becomes incremented by 1. Let me increment that. So pages plus equal to I. So pages, whatever pages was, plus equal to I. I's value is 2. So I add 2 to it. I plus plus becomes 3. Next time it runs. This is actually I is equal to 3. 3 is less than equal to n. It will be true. Then it will be 0 plus 1 plus 2 plus 3. 3 from here. Pages plus equal to I. Sorry, 3 from here. Pages from pages plus equal, whatever is the number of earlier pages plus I. And then we have 4 here. Now in this way, again the same thing we'll say. If it goes on till the last iteration, and the last iteration we say as k, right? The last iteration we say as k, then don't you think here there is a correlation? See, 1, 1, 2, 2, 3, 3. Right? So k will be 0 plus 1 plus 2 plus 3 plus dot 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 k. At the kth iteration, the pages will become like this. Now, pages, when does it stop? See the stopping condition. Now come to the stopping condition. Pages is greater than n is the stopping condition. So the way I am trying to tell you is that increase the count till k. But that would mean that pages will hit the limiting condition of the loop. However number of times you go, at some point pages will hit the limiting condition. So that limiting condition is this. Pages is greater than n is the limiting condition. Right? So pages greater than n means pages is what? This is what? This is k into k plus 1 by 2 arithmetic progression. You all know that 0 plus 1 plus 2 plus 3 plus dot 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 k is k into k plus 1 by 2. So I can say my pages at the penultimate or the last of not even penultimate, at the very end, when pages becomes greater than n, cannot be the exit condition for that will be k into k plus 1 by 2 will be greater than n, because pages has gone from at the value of k, pages has gone here, right? Pages has gone here, and I'm saying pages will exit. So pages will exit. See, pages is exiting. At the kth iteration, pages value is this, and it is exiting means it is satisfying this condition. So if it is satisfying this condition, then k into k plus 1 is equal to 2n, and k square therefore is equal to k square plus k, I can say equal to 2n. I can neglect k for that matter because of the high nature of k. Large number, I told you, asymptotic complexities are always for large values. So the high nature of k, I will neglect this k, and I will say k square is equal to 2n. So if I say k square equal to 2n, then k becomes equal to root over of k square equal to where did I do some mistake? Acha, this 2 k into k plus 1 is okay. Again same thing. What we have to do is we'll have to say that the way I neglected this k, that is, I said that my k, because the high nature of k, the k square will take it to a larger extent than k, therefore k will become insignificant. That's why I neglected that. Similarly, 2 will become insignificant as compared to n because of the large nature of n, and hence we will say that we will neglect 2 also. So k square becomes equal to n, and when k square becomes equal to n, which will imply that k is equal to root over of n. So all you need to remember is, when you can also do this by the standard protocol of solving this equation, right? So you can also say that k square plus k is equal to 2n and solve for k. You will get an order of this only. You can do that and get an order of this only. However, what we will do is, because I hope you understand Taylor series and other things which were there in your mathematics, if you apply that, this becomes negligible and this will also become negligible when you consider a large value of k and a large value of n. Right? So all I'm doing is I'm neglecting those values and I'm utilizing 1 as that constant, and I'm saying that it will be a root over of n. Right? So that's how I'm arriving at this order of complexity for Tn. So Tn here will be written as root over of n. So remember that you need not always have the complexity is in an increasing order. So there will be a complexity table that I will show you subsequently in the next session. But then that's typically what I wanted to show you here. Only the last thing that is remaining is this, which says that write a pseudocode for adding two polynomials which was given by the user, and also comment on the complexity of the program. So there were two polynomials, and the polynomials are 3x square plus 0x plus 5. This was given by the user. How did the user give it? User said, I will give you only the coefficients. So I will give you these coefficients in an array. So I will give you these coefficients in an array, and I will give it to you in reverse order. I'll give it to you in reverse order. So I will give you the coefficient which is 5 first, then I will give you 0, then I will give you 3 as an array, right? So my P1 array is looking like this. My P1 array is looking like 5, then 0, then 3. This is my P1 array. And my P2 array is looking like this. P2 array is x square plus 4x plus 2. So x square means that 1 will be your coefficient, 4 is your x coefficient, and then the last coefficient will come first, which is 2. Now you have to write a code to add these two polynomials. Means what? When you add this, it will be 4x square plus 4x plus 7. So you add these also, you will get 5 plus 2 is 7. So you get one more polynomial which is called as sum. So some polynomial will have 5 plus 2 as 7, 0 plus 4 as 4, 3 plus 4 as 4, right? And you reverse this and print. Reverse this and print as 4x square plus 4x plus 7. So if you print this array, you know that you have to reverse it and print. And when you reverse it and print, you know the first element will be x square. Why? Because you have 3 elements here. So the first element is a constant, second element is power of 1, third element is power of 2, and so on and so forth, you know. So you can hard code things and print the same way it is printed here, right? You can see this print later on and understand how it is printed, but my point is not about the print. The print can be easily done because I know now 4 is x in the x square's place. 4 here, this 4 is in the x1's place, and this 7 is in the constant place, right? If I know that printing is easy, my question is, how after these two polynomials come to you as an array of input, how will you create this sum array, right? Again, it is very simple. First, what we will do is, we will understand whether the two arrays are same or not. It need not be always the same, right? Someone might give me an array like this, saying 5, 7, 9, 10. Someone might give me an array like this, 6, 8, 9. So what is this? This is basically from the beginning we are saying, right? So from the beginning means 10x cube plus 9x square plus 7x plus 5, right? And this is 6. Now this is 6, this is 9x square, 8x plus 6. Right, so these two polynomials are not aligned, right? So these two polynomials are not aligned. Then we'll have to align them first, right? So we'll have to align them first is what we need to do, right? So that's something that you need to do. So alignment happens here. How do we align? We see what is the value of n, right? So n1 we took 3, n2 we took 3 because both the arrays had 3 coefficients coming in. If n1 is greater than n2, then n1 is the largest, otherwise n2 is the largest. So that is my max degree. Now accordingly, my actual sum array will get created. My sum array for these two polynomials will have how many pockets? 4 pockets, because it will be matching the max degree. So it has to match this and not this, and therefore we will take a sum with the max degree, and then we will do what? We will align them with all zeros. So this is a loop that aligns them to all zeros. Then what we do is we just loop through this, and we will add this one time. That is the first polynomial we will, or the array, this array we will take, and we will add it to the sum, each element one by one. So we will have 5, 7, 9, 10 in that. And then we will take the second polynomial and we will add it to that particular polynomial sum which we have. So we will have 6, 8, 9. And then that means that the sum, that sum array which was 5, 7, 9, 10 was now being added with these. So the sum array now has become 5, 13, 17 and 19. So that is what the sum array has become. Now this sum array, if I print in the reverse direction, my job is done. Right? That is the sum of these two polynomials. Right? I took care of disparate indexes, though this algorithm didn't want me to. Disparate number of degrees. Degrees are not the same. I took my sum as the largest degree and I arranged my code in such a way that the proper degrees get added with each other. Right? Proper degrees means cube gets added with cube, square gets added with square, and so on and so forth. Question was, write this code which we have written and also asking you to comment about the complexity. So what is the complexity of this? The complexity, if you see for this particular code, is if I remove all of this now, let us see the complexity part of it. So the complexity part, if I now calculate, see, this will take 1 unit of time. This will take 1 unit of time. This will take 1 unit of time. I hope you understand this by now. This will take 1 unit of time. This will take 1 unit of time. This will take n unit of time. For loop, I++, n unit of time. Anything inside will take n unit of time. Right? Next, this will take n unit of time. Anything inside will take n unit of time. This will take n unit of time. This anything inside will take n unit of time. This print will take 1 unit of time. This for loop is I++, max degree. So everything is okay. It will take n unit of time. Anything inside will take n unit of time, n unit of time, n unit of time. So how many ones we have? 1, 2, 3, 4, 5, 6. How many n's we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What is this? What is this? Can we write this as 10n plus 6? If I can write this as 10n plus 6, then this is equal to y equal to mx plus c. 10n plus 6, y equal to mx plus c. So m is equal to 10 here and c is equal to 6. So what are we looking at? We are looking at a graph like this, where this is 10n plus 6. What is the time complexity of that graph? We have now understood that it will be order of n because that is the highest degree of that linear polynomial. Right? So that's what I wanted to show you from a time complexity calculation perspective. Let us get into quickly one more quiz and then we'll finish the last topic before lunch. So opening up the quiz, let me see the chat window. There is a question on log. Okay, let me see from the beginning. Ghost Coder has asked, sir, if we are dealing with a code having multiple loops, not nested loops, then the code still holds order of n time complexity. Just the example Ghost Coder you saw just now. Multiple loops were there, but it was not nested loop. So you are right, it will be an order of n. Then I see that log n, both side multiply, log base 2. Okay, so you are talking about that log calculation, which is fine. Then we have order of n1 by max. Okay. I didn't understand, Srijib, your question. Order of n1 plus n2 plus max of n1 plus n2. It depends. Order of n1 plus n2. What is n1 and n2? I don't understand. It has to be n, right? It cannot be n1, n2. Right, n1, n2 has to have a value. If you are saying n1, n2 is also n, then it is order of n again. N plus n is order of n. Okay, Shayon, you have given a question. I don't know whether that is for me or for the rest of the people to solve. Size of the inputs for polynomial. Acha, size of the inputs for polynomial. Doesn't matter, Srijib. If the size is whatever that size is, whenever that, yeah, you are right. In the sense your plus is kind of misleading, the last plus. Your order of n1, if n1 is the first size of the polynomial, n2 is the next size of the polynomial, then the time complexity will be actually the max of those two polynomials, whatever it is, but you still write it as n, because as I said, n is a large number. One number here and there, two number here and there doesn't make any difference, right? It will be a linear class of polynomials. It doesn't matter. You are not giving the exact amount of time that you need. You are not saying order of 4 because n is 4. You are not saying order of 5 because n is 5. You are saying order of n, whatever is the n. Now n in between these two polynomials, I don't care. I don't care. It will be a linear curve. Whatever n you take, it will be a linear curve. I am only considered about that linear curve. You are talking about the exact time. I am not considered about the exact time. I hope Srijeev, I could explain you, otherwise please meet me. Shayan, you gave this for me for column major. Okay, please park these questions. Last day, second half, I have kept this for this. Yeah, we will figure it out, Shayan, don't worry about it. Okay, whoever is in the class, there are 132 of you here. Yeah, so Srijeev, you are right, exact time will be that way, whatever you have given, but order still will be order of n. So for all of you, my earnest request is, I will complete a set of questions with all of you. As you are seeing, right, I am completing some set of questions. Beyond this, you have some other doubts, some other questions. Please keep them stored. Sunday second half is when the entire half is free for solving all of these. Right, I will post a Google form either today evening, so that you put those questions there, right, and we will take that Google form on Sunday second half and solve all of that. I will post the Google form, so wait for the Google form. So Shayan, please put that question in the Google form. Okay, I plus plus equal to n unit of time, then value star equal to 2, how much it take? So value star equal to 2 we saw, right? We can't define how much time it will take. So we had to calculate that, right? Whoever that is, Yoja Roy, right? So Yoja Roy, if that is your name, this is what we calculated, right? Because we cannot calculate value star equal to 2, we had to go through the dry run and see if there is a possibility to probably see that the number of times this will run will be somewhat equation. We can draw an equation of that number of times with the value star equal to 2, and that's what we found out, that 4 can be represented as 2. When the count of the iteration is 4, the value becomes 2 to the power 4. When the count of the iteration is k, the value becomes 2 to the power k. That is how we calculate log of n from this particular equation. Okay, that's all I think that is there from the question standpoint. Shomodip Kundu, that was not the intention of keeping this video in YouTube. This video might go away. The intent for you is to interact, talk to me, give me questions to solve. You will get the PPT after this session that you will get. That should not be an issue, but the videos will not be available. Video has to be a live interaction with me. That is from day one. We have made this stance very clear. Marathon is done for a reason. Then I would not have done it live. I could have easily recorded this and given to you. Yes, floor value is needed. I will. It's not floor value. It's ceiling value. Ghost coder. Ceiling value is needed. I will explain that. For lack of time, I am not. If I get time, please remind me, Ghost coder. I will explain you why the ceiling value is needed for log n as far as the order is concerned. It is definitely needed. Do not forget that. So I have given that as a ceiling here. This is the ceiling value, right? So please use the ceiling value. Reason, I will have to give you through some workings in a table. It will take 10 minutes. I will want to defer this as I want to finish off the quiz. So let me do the quiz now. But good, I appreciate that you are interacting with me. That is the whole point of this session. Otherwise I would have done this. Tell once more how the time complexity comes out to be square root of n. अच्छा, square root of n. Square root of n कहाँ था? यहाँ पर था. Yeah. So the square root of n time complexity is when I said that my count is from here. I start my count, and if I take the dry run, then I will see that for I equal to 1, 0 is less than equal to n will be satisfied, and therefore pages plus equal to I will be equal to 0 plus 1, and then I will be getting added. So what is happening? I am saying that this is my value of I with which I will enter, then I will do this comparison, then I will do this increment, and then I will do this increment. So that is what I have written here, 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 and here, right? And I am actually calculating. When I keep on calculating, I will see that at a value of k, I will get this as 0 plus 1 plus 2 plus 3 plus dot 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 k, which is an arithmetic progression k equal to k into k plus 1 by 2. And when I say k into k plus 1 by 2, then this is what? This is the pages value at a value of k, which I am assuming as the last time it is running. So if it is the last time it is running, it is going to cross it, right? If it is crossing it, then pages will be greater than n, because pages less than n is a valid thing, pages greater than n is an invalid thing. So if pages greater than n is an invalid thing, it will cross, then this is my pages. So this becomes substituted here, it is greater than n, right? So if k into k plus 1 is greater than n, then k into k plus 1 is, I can say that it is greater than or equal to as 2n. So I can marginally take it as equal to also, because it's going to be, as I said, a large number. Marginal equal to less than does not matter at all. So k equal to, for our inequality to equality conversion perspective, we are free to do that. So k into k plus 1 equal to 2n will be what is coming out of it. Now, because of the size and nature of k and n, we will be neglecting k and we will be neglecting 2. So that's where we will say k square is equal to n. And when I say k square equal to n, then it comes to k equal to root over of n. That's how we do it, Farhan. Okay. Aditya, you want a channel for last 1 month preparation? You can you can see my channel. I don't know whether you have seen my channel. I'll publish that anyways, but that's where you can be. That has all the modules exactly the way Makaut wants it to be. Only the last module is left. That will also come up in the next I think 14-15 by this December month it will come out. Only the last module is left, Aditya. So you can join that channel. Most of I actually have my friends inside a group where some of the friends are already here in this channel, and they already know about the YouTube group. So there is a playlist of the entire DSA course which you can probably refer to, Aditya. Who is this? Tending to infinity for math? No. Understood, sir. Okay. Ayush. Okay. Okay. Chalo. Let's do the quiz, guys. I think we are getting late. Chalo. Next quiz. I hope all of you get this quiz better. I don't want a 65% performance, guys. Please help to get a better response here. Okay, now time complexity done, asymptotic left, is also left. Okay. Okay, so let's start off time complexity quiz. Let me share my screen. Chalo, come on, quickly. 127 people are here. 32 rather. Let's see. Ashutosh Shaha, please change your profile name to underscore roll number. So we'll start at 110 logins. ...20 more, come on, quickly. Chalo, we'll start. Acha, I think 5 questions only. So let's see quickly. Okay, so let's send it off. 124, 125. Nice, 83%. Good. Swati Gupta, Ayush, Pratyush, new names. Very good. That's what I said. You have ample scope to beat the leaders. Next question. Let's see an above 70% at least correct answers. Quickly. I'll end at 120. Ending 65. Shayon comes up, Pratyush, Disha. The entire leaderboard changed. What happened? Compiler and output. Running time of an algorithm. Time. এতক্ষণ ধরে কি বলছিলাম? TN and the N. The graph that we were talking about. One axis is N. Another axis is time. So the time is expressed as a function of N. Think about the two axes. The time is expressed as a function of N. That means input size. Come on guys. This was easy. Don't get this wrong. Good, we have good participation. Let me close this off. Nice, at least 75. Top 3 doesn't change. Good, okay. Let me move on. All of you, please get this correct. Don't get this incorrect. How many operations? I am hoping for a greater than 85% answer correct here. I hope you have got this correct. closing the quiz. 81. Geetika Kashyap has moved into the leaderboard, okay, but 81. 9 of you answered log n. Why? Why suddenly log n? On what grounds log n? N factorial, n square, kuch bhi na? 1 to n times it will go. Simple. Why make it complicated? Last question. I hope this you get correct. 4 boxes. Only one word can match 4 boxes. I'm ending the question. 78, good, not bad. For a typing question, getting 78% is good. Answer is of course best. Who said loop? Okay, best is the answer. Most of you have answered correctly. Good. So ending this, let's see who is the winner. Okay, Shayan again, you are there. Pratyush is there, new. Geetika, new. Good. Congratulations, guys. We'll see how much you can continue the momentum. Let's move on to and see 76%, which is a decent accuracy for the entire class. So the entire class has participated well, at least in this quiz. So happy for that. Let's move on to the last thing before we break off, which is asymptotic complexities, or asymptotic notation rather. So let me go to this view. Let me switch views. Soham, Gorai, last problem, can you explain once more? Soham, please remind me when we have some time, because we are struggling for time. Please remind me. I will definitely explain, but please remind me when we have some cushion. We have time tomorrow, 1 hour. We have time day after for at least 4-5 hours. So I will explain during that time, Soham. Please don't forget it. Please ask me. I will forget. Okay, so this one I have to bring in. And Soham, I think the problem was around this one, right? That you were asking. Please answer yes or no. This is the same problem that you were asking. To explain once more. Let me move on. Okay, I got your yes, Soham. So good. We will solve that, or we will discuss that problem again. So this is what I wanted to show you guys. So people who are taking my classes, they already know about this diagram. Others might have also seen this diagram. But what does this diagram try to say? And what is asymptotic notation? What is this O? What is this omega? What is this theta? Is what we are trying to talk to you about. Now see, the thing is that whatever complexities we were finding out, right, we were writing it as time complexity is equal to big O of something. Big O of something. That is what we were trying to write always. Right? So this big O has some meaning. It says that your running time for the algorithm will be of this order. That's what it says. Now, there are some facts or some types of classes that we call as complexity classes, which have been defined as well-defined complexity classes, right? So there are some well-defined complexity classes that we are aware of. These well-defined complexity classes are what you see in this table. Against any polynomial, because every code that you see got converted into a polynomial. you see this code, I converted it into a polynomial, 10n plus 6. You see this code, I converted, this one I did not convert because it was not possible. This one also I did not convert. This one I converted into a polynomial. This one I converted into a polynomial. So every code I converted into a polynomial whenever the count, the dry run was not required. Whenever the I++ was in a linear or non-linear, in a linear increasing or decreasing manner. So every code I converted into a polynomial. So every code, even the codes which I could not convert into a polynomial and wanted to do a dry run, if you convert that into a polynomial, that will also convert to a polynomial. From the dry run you got the order, and from that order you can actually convert it into that. Basically is your starting polynomial. Log n is your starting polynomial, right? We don't call it exactly as a polynomial. Logarithmic is a logarithmic. It's not a polynomial at the end of the day. But what I'm trying to say, I hope you can understand. So every code can be converted to something like this or this. Every code, right? That it will be a function of n or not a function of n. I told you, right? Originally I told you that you'll have to figure out whether your code is dependent on n or not, right? If it is not dependent on n, then it is constant. If it is dependent on n, then figure out to what extent it is dependent on n, whether it is linear, whether it is quadratic, etc., etc. That's something that I told you in the beginning. So from that standpoint, if you see, all of these will be actually replicating, or will be trying to resonate to one of the well-defined complexity classes. What are the complexity classes that are well-defined? Order of 1, order of log n, order of n log n, n square, n cube, exponent, worst is order of n factorial. So what do these, why it is worse? Because that takes the highest amount of time. So what does this mean? It means, given an algorithm, that algorithm will be, whatever that polynomial comes from that algorithm will be either this or this or this or this or this or this or this, because they are well defined. The algorithm will marry with one of the lines because these are well defined complexity classes. They will represent one of the orders. This Tn equal to 6 represents this line, constant order of 1. 3n plus 6 represents what? Linear, right? 3n plus 6 is y equal to mx plus c. 4n square plus 5n plus 2 is what? Quadratic, right? So it represents quadratic. But it's not happy path for everybody. This particular polynomial does not have any takers here. It does not marry to any one of the complexity classes, well-defined complexity classes. So let's say you created this polynomial and you want to sell this now to the market. What will you tell to the buyer? What is the complexity? You can't say anything. You can't say anything to the complex buyer because you don't know the complexity is not marrying to any of these complexity classes. How will you tell the buyer that this is this complexity class? Buy it. You can't. Right? So if you actually draw this line will be somewhere here. That will be what this Tn is. So this Tn doesn't have a well-defined complexity class. How do you then define this Tn to an external user? That this is my performance. Right? One of the performance requirement was complexity, and we are talking complexity. So this is my performance. So then you will tell them that I don't know. Tn I don't know. But I know that it will have the highest complexity of this particular person and the lowest complexity of this particular person. It will be in between. That is what you will tell. So instead of you telling your own complexity, which you don't know, you will tell one above you and one below you. The one above you is called as big O. The one below you is called as omega. So this is called as your upper bound. The one above you is the upper bound. Your complexity cannot go beyond that. Whatever is the complexity, your complexity cannot go beyond that. And your complexity cannot come below the logarithmic order of log n, which is your omega, which is your lower bound. Right? So it cannot go below this. And if you actually know your complexity, then that is called as theta, which is the average or tight bound complexity. So which we don't know. If we knew, then it would have been called as average or tight bound complexity. So we talked about not knowing a complexity means that whoever is above us in this chart will be an upper bound to us, whoever is lower to us will be a lower bound to us. We will not go below or above that. And ourselves will be at theta. So in that case, if I tell you what is the big O, okay, let me give you a problem statement to solve. Tell me for Tn, you can type it in the chat window. Okay, tell me for Tn equal to 4n cube plus 4n square plus 5n plus 2. What is big O? What is theta? What is omega? Tell me. Big O, omega, theta, all three of them. Quickly. Achha guys, tell me if the camera switches off, because if I get a phone, the camera switches off. So just tell me that. Big O is n cube, theta is n cube, omega is n cube. Shayan Das, upper bound, best case, same. Okay, I'll answer that. All of you are answering. Okay, some of you have answered omega is n. Yeah, so that is what I wanted to probably clarify. Rupsha, you have answered order of n cube, which is fine, but I want to understand what is theta and what is omega also. Theta is n. No. Sneha. No. Okay, let me explain. So when you have, why is this chart required? Just now I have explained. When you don't have a complexity, then this chart is required. Right? So that's what I explained. When you don't have a complexity, then this chart is required. So you have a complexity here, a well-defined complexity. Don't you? You have a well-defined complexity here, which is quadratic. So it easily marries with this curve. It easily marries with this curve, right? It's a well-defined complexity. First of all, you don't even need this chart to tell somebody, because asymptotic notation, what did I tell you? It is needed to actually express to somebody when you don't have anything, right? So when you don't have anything, you express that with whatever is your upper bound or with your lower bound. That's what I explained to you. But you have something. That is what? That is actually your tight bound. No? That is your average bound or tight bound. So your theta definitely has to be n cube. Your theta cannot be anything else. It has to be n cube, right? So theta has to be n cube. Why? Because that's your complexity. Theta is your complexity. Always average bound or tight bound is your complexity. So theta is your complexity. If theta is your complexity, then because it is a well-defined complexity class, the upper bound is also n cube. The lower bound is also n cube, because it is a well-defined complexity class. If it is not if it is an in-between curve, then only you see upper bound here and lower bound here. But if it is in a curve which is well defined, then your theta, big O and omega, all of them will be the same. All of them will be the same. I hope that is making things clear. So Next is what Shayan you are asking. Shayan, you are asking that is it the same best case, worst case, big O, and that is something that I have been pretty much vocal about. Suppose this particular equation, how did you arrive at this particular equation? Let us talk about this particular equation. So again, I'll repeat what Shayan's question is. Shayan is saying that is big O the worst case or best case? Is omega the worst case? Right? And is theta my average case? Case and bound are two different things. Right? What is best case? Best case is when you actually execute it in the earliest possible time. That is the best case. Can you tell me when this polynomial was created, this 3n plus 6, was it created because n was assumed to be worst case? Right? Let's say a searching algorithm. A searching algorithm, linear search, just pakad lo linear search. Linear search, you said the time taken to search will be what? Linear search, time taken to search will be n. When? That is the worst case. You said worst case. That's what you said. Right? So let's say the time taken to search for an element in a linear search is at the last. At the last means I will take n iterations to go there, which means it is the worst case. Right? So Tn will be equal to n. Tn will be equal to n. Now this Tn equal to n, when you plot it here, right? When you plot it here, where is n? Where is my n? Here. So Tn equal to n, you will plot here. What are you plotting? Shayan, what are you plotting? You are plotting the worst case. So worst case का क्या best case और क्या worst case फिर से? You are already plotting a worst case. So depends on how this got calculated. This is a worst case calculation. If you are plotting it here, then you are saying this is my best case of this worst case. And this is the worst case of this best case or worst case of this worst case. Because this line is the worst case line, worst case time. So order and case are different. So this order is actually what? This order is a worst case, this case, this line is of worst case. This line being of worst case has no significance in calling the best case, in calling big O or omega from these two lines. So if I plot a line here, if I plot a line like linear line like this, and if this is the worst case linear line, then can I say that this is the best case? If you say O is best case, then best case of worst case. So the worst case line has a top bound, right? So then that will become my best case of worst case. So contradictory, right? So that's why the worst case line, that line itself is defining what that case is, because that is how it has been calculated. It has been calculated with one assumption, that it is a worst case calculation, it is a best case calculation. After that you are coming here and finding out what is the boundaries. Now for a line which is Tn equal to n, it is very much close to this or very much aligned to linear. So all of its theta, omega and big O will be the same as n. Right? So all of that will be n. Because as I said, if somebody is exactly one of these classes, then all three will be the same. Right? And therefore when I represent something, I will always represent it as theta. If I am a match with any one of them, I will not represent it as big O. I will represent it as theta, because that's my complexity. Right? That's my complexity. Average case complexity, tight bound complexity is my complexity. Because my upper bound and lower bound can be different in different cases. Here it is not. But if I was like this, then it would have been different. So always I will represent my complexity as theta. I hope, Shayan, I could answer your question. Okay, now let's move on. We have 20 more minutes, so 10 more minutes we'll finish, 10 more minutes quiz, we'll break at 1. Okay, now this is big O. So big O is what does it say? It says that if I have somebody who is complex, I don't know my complexity. Now you know your complexity, n square is there, you know this is quadratic, but I am saying hold on. Let's say this you don't know. I mean, let's say this is not 1000 square. This is something else which is drastically different than this, but the graph looks like this, and let us assume that this is very complex. I don't know the complexity of this, let's say. So if I don't know the complexity of this, what did I tell you? That there will be a line at the top which will be your upper bound, which you cannot cross. There will be a line at the top which will be your upper bound, which you cannot cross. Right? And the logic of that is that it will only happen after a particular value of n. Right? You have to say that it will happen at a particular value of n, that this, see, these two lines will never cross each other in their entire lifetime. This cross has happened, never ever will they cross each other. That means after this point, this particular person whose complexity we don't know, assuming, will or can rely definitely on the complexity of this person to say that that is my upper bound. So this becomes the upper bound line. Right? So if this is the upper bound line, then we can therefore say that the function fn here has an order big O, because it is upper bound, big O of Gn. Right? Big O of Gn. That is the big O definition. That if such a line, such two lines are there, where one line is above the other and happens at n equal to n0, and that one line that is above the other has Cgn, some constant multiplied by a polynomial, then the function fn upper bound will be order of Gn. That means this will say, okay, I need an upper bound. He'll say, come, I am Gn, I will give you the upper bound. Gn is the upper bound. And Gn is equal to n cube. Right? So the upper bound for all practical purposes can be considered as n cube for this function fn. So that is your big O, how big O can be visualized, right? How big O can be. And this question has come. They will give you this kind of a question and say that does it represent upper bound? Cgn is greater than fn. Does it represent upper bound? Cgn is less than fn. Does it represent lower bound? Let us see that. If Cgn is less than fn, see Cgn here, less than fn. Fn is here, Cgn is here. This is less, Cgn is less. Right? So if Cgn is less than fn, then fn again, assume fn is very complicated to calculate. It doesn't marry with any complexity class. So then I am relying on what? I am relying on the lower bound or the upper bound to say to my whoever is trying to buy it. Right? So if I am actually talking about my lower bound, I will say I don't know myself, but I know that after n0 I can rely on Gn to be my lower bound. So if Gn is my lower bound, then I will write omega as my lower bound, which is omega of Gn. So my fn will be equal to omega of Gn. So my function, that is this one, this function fn will be as omega of Gn. Right? Because Gn is the polynomial of that lower bound. Right? At n equal to or greater than n equal to n naught. And because Gn is equal to n cube, so we can definitely write omega of n cube here. So I hope you are understanding the concept. At some value of n naught, there will be a situation where there will be a line at the top, there will be a line at the bottom. The line at the top will have a Gn and a constant. The line at the bottom will have a Gn and a constant. And we will take Gn as the order. Top means big O, bottom means omega. That's all there is to it. Right? And if you just aggregate both of them, you will get theta, which is your tight bound, right? The average bound. So then what it says is at the top there will be a C2Gn, and so you are here, your complexity you don't know. Let's say your complexity you don't know. Then you will rely on somebody here, which is above you, lower you, right? So then if the above you person, now you might say then this is big O, this is omega, Yes, they are big O and omega for us. But there is a special case here. Can you see the special case that both of these are GNs? Both are GNs. Only the constants are differing. Right? C1 and C2. But both are GNs. Which means one of them is 10 times n, another is 5 times n. Right? So in that case, when Gn is the same for both the lines, but C2s are different, then you don't call it as upper bound, lower bound, you call it as the tight bound. So what we'll say is Fn therefore will be of theta of the same Gn, and which will be equal to theta of n, because 10n is nothing but n. So I hope you are understanding this, why or how we are talking about upper bound, lower bound and theta. Right? So, and don't forget that anybody in this hierarchy can be your upper bound or lower bound. That is not the question. See, if I am here, my upper bound can be this person, can be this person, can be this person. I know I am perfectly marrying this class. Then my lower bound, upper bound, tight bound, all is the same. I have told that, yes, I am saying that. But at the same time, I am also saying still there will be an upper bound here, there is still an upper bound here, there is still an upper bound here, if there was anything there. And there is still a lower bound here, lower bound here, lower bound here. What does that mean? That means that even though you are here, your upper bound is here. I'm sorry for that. Yeah. So even though you are here, your upper bound is here, your lower bound is here, your next upper bound is here, your next lower bound is here, your next to next upper bound is here. So upper bound is upper bound. Whether it is the immediate upper bound defines whether you have married that class or not. When you marry that class, your immediate upper bound is yourself. If you don't marry that class, your immediate upper bound is the next upper bound. I hope this is making things clearer. So, some kind of questions that come, is tight lower bound same as tight bound? Anything tight is the same as the average bound, right? So, that way just consider it as theta. Whenever you see the word tight, whether it is tight lower bound, tight upper bound, don't care. Tight means you know what your class is, complexity class is. And that's why when you know something, it is theta. When you don't know something, you rely on omega and big O. Which notation comprises, see I told you such a question comes, which notation comprises set of functions Hn that are greater than equal to Cgn? Hn, that means my line which is complex is greater than another line. That means which notation? That means another line is below me, na? That means lower bound. Lower bound means what? Omega. So omega is the answer. My line Hn is bigger than the other line, right? So that means omega, right? I hope that part you can understand. Hn is greater than or equal to Cgn. Your function is Hn greater than equal to Cgn. So that is done. Now let's try to see, this kind of a problem also had come once. In fact, this is a gate problem. So if you see this problem, it says find out so it says find out the this one. Okay, so what we'll do is, for big O we will say 5n square plus 2n plus 3. If we have to create a big O out of this, then let us assume we take the powers as the highest power. Highest power was n square. I substituted n square here. I substituted n square here. So what do I get? 5 plus 2, 7, 10n square. Right? So 10n square is Cgn. Right? So what am I trying to do? I am trying to create O, na? Big O. Big O means for this function, I have to find somebody above it. So I have to find somebody greater than, right? Greater than equal to. So that somebody is this, who will be greater than equal to the actual Fn. So this is my Fn and this is my Cgn. So this Cgn will be greater than Fn because I have taken n square, it will be greater than, na? This is 5n square plus 2n plus 3. 5n square plus 2n square plus 3n square will be always greater than fn. So this becomes cgn. Then what is my gn here? Gn here is n square. If gn here is n square, then my big O becomes n square. Simple. Right? So all I did was I proved that here what is happening, I have proved, and I can prove it that at n equal to 1, my this fn is what? My fn is 5 plus 2 plus 3. In fact, let us take n equal to 2. I don't know what value of n. Okay, let's take n equal to 10. Let's see with 10. So this becomes 5 plus 10 square, 500 plus 2n, 20 plus 3. So 523. Fn is 523. And what is my right hand side? 5n square. 5n square is 500. So cgn is 500 plus 2n square. 2n square is 2 into 100, which is 200, plus 3n square, 300. What is this? This is coming as 500 plus 200 plus 300 is 1000. So can you see cgn is greater than fn at n equal to 10 or n greater than equal to 10? So we are satisfying that condition. I hope you can remember the chart, and now you can see that cgn is greater than fn. And if cgn is greater than fn, then can I say that the fn has a time, the big O of fn will be gn, big O of gn, and big O of gn is what? N square, because cgn is 10n square. So this will be big O of n square. So what I have to do in order to do this sum, I have to do two things. One, I have to prove that for a particular value of n, this side is greater than this side. That I have to prove. For that I took this trick. I made use of this trick, that I'll make everything n square and see what is cgn. Right? And the second thing that you have to do is, once you have proved that, take cgn and call it out in the order. That's all. So if I now calculate theta, then fn is equal to 5n square plus 2n plus 3, whereas for my theta I will eliminate everything. I will just take 5n square. Right? So this I will say as cgn. Then what is my gn here? N square. Now can I prove? But when I say not theta, when I say I'm talking about omega, this has to be what? Niche, lower, right? So if this has to be lower, this has to be greater, fn has to be greater. So of course 5n square plus 2n plus 3 will be greater than 5n square, na? Of course that will happen. Prove it. N equal to 1. Let's take n equal to 1. 5 plus 2 plus 3. What is that? 10. 10 is greater than 5. Yes, 10 is greater than 5. If I take n equal to 1 on that side. So then fn is proved at n equal to 1. Fn is greater than cgn. And that becomes the main criteria for saying that my fn has an omega of gn, which is equal to omega of n square. So that is where you find out the omega of n square. Do you see what I wanted to tell you? Do you see that 5n square plus n cube 2n plus 3 is a conventional complexity class? Don't you see this? This is a conventional complexity class of quadratic. Quadratic means n square. So do you see your big O is also coming n square? Your fn omega is also coming n square. That is what I was trying to tell you. That your immediate big O and immediate omega will be the same as theta. After that you do whatever you want. Next big O, next omega, next theta, whatever you want. So I hope this is becoming clearer. The running time complexity of a linear time algorithm is running time complexity of a linear time algorithm. What is the running time complexity of a linear time algorithm? Chat box. Running time complexity of a linear time algorithm. Time complexity cannot be linear, Babu. Zekil, Zeniki. अरे भाई नाम टा तो ठीक करे दे. Okay. Learning time complexity of linear time algorithm is order of n or n, whatever you want to call it. Everybody is right. It will be big O of n. Actually, I will write it as theta of n. For me, if I know myself, then I will be theta. Unless it says worst case, best case, average case, then people want us to write big O, omega and theta. Though I don't agree with that, I have explained you why. Right? Some of the examiners might want you to write big O for best case, omega for worst case. So take it with a pinch of salt. I have just explained you why. Define asymptotic notation, explain each types. I hope you can do that. Which notation comprises a set of functions hn that are greater than? We have also seen this. Right? So this is omega. Right? So we have seen this also. Okay, so I forgot that we had searches to cover and this was not accommodated in the time for that matter. So we will have to anyway do searches after the lunch break and then continue with our second half series. So for now, let us do the quiz and break out for lunch. We have 5 more minutes, so we can, I think, finish the quiz by that time. Let me see any questions. There are 2 functions, hn, gn, given hn. How can I determine which my complex function to bind, upper bound, lower bound? Is it given? Anirban Khandra, I think we need to discuss this. I don't understand completely. As I said, put this in the Google Sheet that I will be circulating tonight, and we will discuss this at length. Please keep this question in the Google Sheets. We will discuss it in either Sunday or tomorrow. What should I write in exam, big O or theta? See, if it is asking what is the complexity without asking best case, worst case, average case, then write theta. How will attendance for each session will be marked? Babu, there is no attendance requirement. This is just for your benefit. There is no attendance requirement. Right? All I would do is, I would see that you have attended a sufficient portion of the class. 8 hours sufficient portion means at least half to more than half class you have attended. In each of the days, you will be eligible for the certificate. Rest is up to you. Okay, now changing the screen. Chalo, quickly. Please scan. How many of you are here? 112. 5 more. We'll start with 95. 96. Okay, good to start. Okay, we will end it at 100. Yes, okay, we'll end it. What happened? So bad. This was not big O. This was theta. There is a dot in between. Theta is also big theta. Omega is also big omega. In case you don't know. So it's not just big O. Theta and omega are also big. They are also called big theta, big omega. Right? So all 48 of you, I understand why you were confused. But 48, 43 milake, I think we would have been 90. So which is okay. I don't mind that. But I hope you have rectified this. This is a 10 question quiz. So let's move on a bit faster. Remember the graph.